Hello folks, in this tutorial series we're going to be making a tower defense game from scratch. This game will have all the typical features including multiple waves of enemies to defend against, different enemy types, as well as upgradable turrets. We're going to start by setting up a single enemy object that can move across a screen. Then I'll create manual waypoints and add in some AI to follow those waypoints from start to finish. After that, I will create a full game map with a path for the enemies to walk along using the free tile map editing software Tiled. We will set up turrets, add buttons and animations, and a lot more. All the code and assets will be linked in the video description. First, let's take a look at how the project is set up. You will need to make sure that you have installed Python and Pygame. You will also need an editor to type your code in. I use Sublime Text, but there are many other options to choose from. If you're not sure how to install Pygame or how to set up an editor, then I have a short video on getting started that you can check out first. Next, we'll look at the folder structure. I have a root folder for my game here, and inside it I've got my main.py and constants.py files. There will be a few other files created as we go, but for now this is all that's needed. There's also an assets folder that contains all the images and sounds that we're going to use, as well as a levels folder that contains the data for our game map. We're not going to need these just yet, but it's good to understand how the project is laid out from the beginning. I'm going to hide this panel on the left so we have a bit more space. Now to start this project we need to import Pygame. And as a shorthand, I'll import it as PG. This means that whenever I need to call a Pygame function, I can just type PG without having to type the whole thing. Next, we want to initialize the module. So I'll say in a comment, initialize Pygame, and I'll call pg.init. Now I can set up my game window. I'll add a comment to say create game window, and this is done by assigning it to a variable. So my game window is going to be assigned to variable screen, and I will make that equal to pg.display.set_mode. And within here, I need to pass in two variables, my width of 500 pixels and my height of 500 pixels. I can run this code to test it, and you'll see that something pops up for a second and then disappears again. The code is executing line by line, so it initializes Pygame and then it creates this screen variable, but then there's nothing to follow on afterwards. What I need is a way for the game to continue running until I close it down manually. And to do that, we will use a while loop. So a while loop will continue running as long as a condition is met. And this condition can be anything you like. So what we'll do is create a variable up here called run and set that variable to true. And then down here, I'll just say while run. And this means that as long as the run variable is true, this while loop is going to continue executing. So we'll just comment that to say game loop. If I was to run this game now, then we would go into this while loop and then get stuck inside it because there's nothing else there and there's no way to exit it. So the game would just hang up. What I need is a way of taking player input using the mouse and the keyboard to allow me to actually control this while loop. And that's going to be done with an event handler. I'll add a comment here to say event handler. Events in Pygame are added into an event queue and we can iterate through them with a for loop. I'm going to say for event in pg.event.get. And for the time being, I only need one event, which will allow me to close the game down. So I'll add a comment to say quit program, and I will look for this specific event with an if statement. I'll say if event.type is equal to pygame or pg.quit, all in caps, then I can exit this while loop. Now the while loop, as we mentioned before, is contingent on this variable here being true. That means that to exit the while loop, I simply need to set this variable to false. So I can do that in here, and I will exit the while loop for me. Lastly, once all of that is done and outside of this while loop, I'm going to just say pg.quit. So at the very beginning, we initialized Pygame with pg.init, and at the very end, we quit. If I run this now, I get my game window, and you'll see that it stays up, it didn't disappear like it did before. And now if I click up here, the game closes down. The next thing we'll do is limit the frame rate. This will mean that it will run the same speed regardless of how powerful the computer is. To do that, we need to do a couple of things. So I'll go at the top here, just underneath where I've initialized Pygame, and I will create the clock. And that's going to be assigned to a variable clock, which will be equal to pg.time.clock. Now inside my game loop, as the very first action, I want to call that clock variable and say .tick at a frame rate of 60 frames per second, which is pretty standard for games. The setup is mostly complete, but we've manually entered some values into these fields. A tidier approach would be to define these as variables and then pass those variables into here instead. So we can do that up here. Since these are constants, meaning that they're not going to change throughout the game, the convention would be to use capitals to define them. We'll say screen_width is equal to 500 pixels, and screen underscore height is also equal to 500 pixels. And lastly, the frame rate, FPS, is limited to 60. Now these are the same variables here and here, so now I can just replace them. I'll replace this with screen width, and I can replace this one with screen height. And likewise, I can change this to FPS. But as the game grows, then so will this list, and that could become a little bit messy. So that's where this constants.py file comes in. What I'm going to do is cut these out from here and paste them into this file instead. But now, to be able to access these variables, I need to make sure that I import the constants file into my main file. At the top here, I will say import constants. And to give myself a shorthand, I'll import them as C. So now I can still use these variables as before, but I have to add C dot at the beginning of them. And with that done, I can run the game again, and everything works just as it did before. So before we close this section out, there's one little thing that I want to update here. In the game window, it literally does just say Pygame window. So I'm going to change that to say tower defense. And we'll do that just after we create the screen. We'll say pg.display.set_caption. And in here we pass in the string that we want to appear instead. So in my case, I will call this tower defense. And if I run this again, you can see it's now replaced. Now that the game structure is set up, we can move on to creating the enemies. For this, you'll need to create a new file called enemy.py and put it inside the game folder, just like this. I'll begin by creating an enemy class. I'll say class enemy. And within that, I'll have my constructor, which will be def_init. And within here, I pass in the argument self, the position, and the image that I want to use for each enemy. Next, we can assign these variables by saying self.image is equal to image. Then self.rect is going to be derived from that image. So we'll use get_rect method. And lastly, we'll position that rectangle's center at the pos coordinate that we pass in here. And this would be fine for creating a standard Python class. But what I would like to actually use here is a Pygame sprite class. It works in much the same way, but it gives us just a little bit more functionality. So to do that, I need to import Pygame at the top here. So I'll say import Pygame as PG. Just like before, we'll use that PG shorthand. And then to make this enemy class into a sprite class, I simply need to add inheritance. So in here, in these brackets, I add in the name of the Pygame sprite class, which is pg.sprite.sprite. And the second sprite starts with a capital S. This will take the sprite class and it will make it a parent of this enemy class. So the enemy class will inherit all of the functionality that comes as standard within here. At this point, the difference between the classes might not be very clear, but as we go further on, I'll demonstrate what additional functionality this will give us. Now, in addition to calling the sprite class here, we also need to call its init method inside our own class's init method. So just in here, we'll say pg.sprite.sprite with a capital S, and then we just call init with self inside it. That gives us the enemy class, and that's all we need for now. So we'll go back into our main file, and within here we need to do a couple of things. First of all, we need to load in an image that we can pass into this enemy class. And I'll create a section down here just underneath the game window, and I'll say add a comment to say load images, and this will be enemy_image is equal to pg.image.load. And within here, I need to pass the location of that file. I previously touched on these two folders here, so we can have a look at this in a bit more detail. If we go into assets, images, and enemies, we can see that I've got 4 different enemy images. So for this, I'm just going to load in the first one, which is enemy_1. But I'm starting from this root folder up here. So I need to pass in all of this additional folder names. So we'll put in our quotation and we'll say the folder starts with assets /images/enemies/enemy_1 png. Right, so that's the root of how we get through to that image following these folders. And finally at the end we add .convert_alpha. If you run this and you encounter an error here that says that the file can't be found, there's a few different reasons why this could be happening. First of all, just check for typos. It could be that you've misspelt one of the letters or the names in here. Secondly, make sure that this file is actually in the correct folder, that you've downloaded and set them up correctly. And lastly, another reason for this could be that if you're using an editor, for example, VS Code, you need to make sure that you're opening the folder that I've got here. So you're open within your root folder. You aren't opening a different folder and then navigating to this one, because if you do that, sometimes it's also unable to find the files. So now we've got the enemy image and we should be able to create an enemy instance. However, this code here, this class, doesn't appear inside the main file. We need to make sure that we import it right at the top here. From enemy, import enemy. And what this says is go into this file, enemy.py, which is here, and import the enemy class. So you notice the difference between the capital letter and the small e. Now we can create an enemy down here. So after we load the image, I will say enemy is equal to an instance of the enemy class, and then I need to pass in the arguments in the correct order. The first one was position. We ignore the self argument. So the first one is position, and then it's the image. For the position, I will pass in X and Y coordinates of 200, 300, and for the image, we just pass in the enemy image that we loaded. Now let's run this just to make sure there's no errors. So everything works fine. We don't see anything displayed at the moment. However, we didn't get any errors. That means that the image loaded correctly, and this instance was also created correctly. So to test that, we can say print enemy. And if I run it again, we should see down the bottom it says enemy class, and it's a sprite. It appears in 0 groups. And that brings us on to the next point, which is groups. So because we're going to have many different enemies in the game, we want to be able to have a way of organizing together and applying all the functionality to them all at once. To do that, we will use groups. So above this section, so before I'm actually creating the enemy class, or sorry, the enemy instance, I will add a comment to say create groups, and we will build this over time. But for now, the only group we have is the enemy group. And we'll say that is equal to pg.sprite.group. Now, once I've created my enemy instance, I can add it into this group. We can say enemy_group.add enemy. This functionality is quite similar to Python lists. So if this was a list, you would say .append, and you would include the enemy inside that list. Now we're finally ready to try drawing these on the screen. We'll go into our game loop, and underneath this clock.tick section, I'll add a comment to say draw groups. I'll say enemy_group.draw, and the location I want to draw on is the screen. If I run this now, we would expect it to appear on the screen, but still nothing seems to be changing. The reason for that is within this while loop. Throughout this while loop, we will have many different draw methods being called, and all of these will get added to sort of a queue. And the idea is that at the end of the while loop, we want to take all of those things, all of those changes, and update our display with them. So for that, at the bottom of the while loop, so make sure that it's indented once here, we'll say update display, and we'll say pg.display.flip. If I run it again, you can now see this little enemy coming up at the bottom. At this point, some of you may have noticed something here. So I've got enemy group and I'm calling a draw method. But if I go into my enemy class, there isn't a draw method here. I haven't created one. Normally, if you try to call a method that doesn't exist, you will get an error. But in this case, it's working fine. It's taking the images and drawing them on the screen. Well, this is one of the reasons why I've set this up as a sprite class and I've added this inheritance. So the sprite class does have a draw method, as does the sprite group. And by inheriting that through into this enemy class, we add that functionality. We bring it through without having to manually create it. So now, it doesn't matter how many enemies I create, by simply calling this one line and adding them all inside my group, it will automatically draw them on the screen. This just helps to keep everything a little bit more organized and makes it easier to work with large numbers of individual sprites and images. Now let's add a little bit of functionality to the enemy. Let's have him move across the screen. For that, I'm going to create a move method. We'll say define move. It doesn't need any arguments, so we'll just put self inside it. And to move it across the screen, we simply update the x coordinate of the rectangle by, say, 1 pixel. So every iteration of this game, we will move by 1 pixel to the right. Now let's go back into our game and call this move method. I'm going to do it above the draw section, and I will say enemy.move. If I run this, you see the enemy starts to move across the screen. It does leave this trail, but we'll deal with that in a second. Now this is fine because we know that we've got this one instance, but as the game progresses, we're going to have a whole bunch of enemies. So it's not practical to type this out for every single enemy. Of course, we will add them into this enemy group. So what we could do, similar to a list, is say for enemy in enemy group, and then we call this method. So now it's going to do the same thing, but it won't matter how many enemies are in that group. It's going to run it for each one of them for us. And that's fine, but we can simplify this even further. So if you remember from before, the enemy group has this draw method, which we never defined. Well, there's another method, which is the update method, which we also don't need to define. So if I add a comment here to say update groups, and I'll get rid of this, and I'm going to type it exactly the same way as below. So it's going to be enemy group, and now it's going to be update. So if I run this, nothing happens like before, but I don't get an error. I'm able to call an update method. It's just that the update method right now is empty. If I go into my enemy class and I create an update method, then I will override the default one. So I say define update self, and from here I can call that move method. And over time, as this game develops, this class will grow, and we'll have other methods that we'll be able to call from the update method. So now if we run this again, it goes back to how it was before. So the enemy is moving across the screen, and it's all being handled by this update method here. I don't need to iterate, I simply call it on the entire group. The last thing then is just to fix this issue with this trail that we're leaving behind. The reason this happens is because we're not clearing the screen in between frames. So every frame, the soldier or the enemy moves across a little bit, but the previous instance remains where it is. So what we need to do is refresh the screen every time. We need to draw something else in its place. So we're just going to draw a background. The easiest way to do that is just to add a section here which will say screen, which is our game window, dot fill, and that will fill it with a color. So I'm going to call gray 100, run it again, and now we fill it with a white background every frame, and we have the enemy moving across seamlessly. Now that the enemy is set up, let's give it a path to follow. We will create a proper level further on, but for now I will manually set up some waypoints. So just underneath here where I'm creating my enemy group, I'm going to add a temporary section where I'll create a list called waypoints. And inside this list is going to be a combination of X and Y coordinates. So we'll put 100 and 100, then another one which will be 400 and 200, 400 and 100, and then the last one will be 200 and 300. And you can play around with these, you can set whatever you like, because these are just temporary waypoints that we'll use for the time being. And just so that we can visualize these waypoints, we'll draw them out as a set of lines. So just after I fill the screen with this white color, I'm going to add a section here which will say draw enemy path. I'll call pg.draw.lines. I'll draw it onto our screen. I need to define a color, so we'll say gray 0. The next argument is whether we want to close the lines as a polygon or just a series of lines. So I'm going to put false so that it doesn't close it as a polygon. And lastly, I'll pass in my waypoints list. If I test this out, we should now get these waypoints drawn up on the screen. The next thing to do is get the enemy to actually follow these. So I'm going to pass the waypoints list into the enemy instance when I create it. At the moment, we've got this manually created variable that's used as the position. This is the starting point. We'll delete that and we'll pass the waypoints instead. And of course, now we need to update the enemy class because it's expecting X and Y coordinates to appear in this pos variable, but now instead we're sending in a list. So we'll change that to say waypoints, and we'll assign that to a self variable. I'll say self.waypoints is equal to waypoints. Using this waypoints list, I can now extract that pos variable that we had to begin with. So this is the initial starting point of the enemy. And that's just going to be the first index, or rather the 0 index in the waypoints list. So we'll say self.waypoints at index 0. And lastly, I just need to change this here to self.pos. Now I can run the game again, and the enemy starts off up here. Of course, he doesn't follow the lines yet, but he's starting off in the correct point. Now, one challenge with these waypoints is that they create an angled line between them. So to work out the angle and to work out how to move the enemy across these lines, we'll need to do a little bit of maths with a bit of trigonometry. But fortunately, Pygame does have a built-in module that makes that easier. That module is called vector2. So in the enemy class, I'm going to import from pygame.math the module vector2. Now I can change this self.pos variable into a vector. I can add vector2 and wrap it in brackets, and now nothing actually changes from the look of it. It still starts in the same point, it runs the same way, but we do have a little bit more functionality now on this self.pos variable. For now, you don't need to worry too much about this, but as we progress, I will explain what the functions do. Now let's get the enemy to actually follow that first line. So let's get it to move from the initial starting point onto the next waypoint. Well, we've got the initial starting point here in this pos variable, so let's define the target. I'll say self.target_waypoint is going to be waypoint 1. Now you could say that, well, it's already at the first waypoint, so there should be 2, but because we're working with a list, waypoint 0 is where everything begins. So waypoint 1 is going to be the next one to move to from that start point. We can now use this to define a target for the enemy. We'll go into this move method again and add a comment to say define a target waypoint. And this target is going to be self.target is equal to, and again here we're going to use vector 2. So we'll have vector 2 for the current position and vector 2 for the target position. And the target is going to be taken from the waypoint list, because that's where all of the waypoints are. And the index we use is the target waypoint. So we begin at index 0, that's our starting position. Then our target waypoint variable is 1, which is what we put in here. So our target becomes the next waypoint. We can now use those two variables to work out the distance between them. I'll say self.movement is equal to self.target minus self.pause. And we don't need this section anymore because we're not just having the enemy move slowly across the screen. So for now, let's just print out the self.movement variable and see what it is. If I run this code again, at the bottom you see it displays 300 and 100. Well, if you look at our first two waypoints, the first one is at 100x and 100y. The second one is 400x, 200y. The difference between them from 100 to 400 is 300, and 100 to 200 is 100. So that's what this new variable here is showing us, is the distance between the two waypoints. So what do we actually do with this? Well, like I mentioned before, we could use trigonometry here. So we could use this 300 as the x distance, 100 as the y distance, draw that as a triangle, use Pythagoras to work out the angle, and so on. But there's a much easier way to do it using vector 2 methods, and that is the normalize method. So instead of printing out just a movement variable, we'll add normalize at the end of it. If I now run this again, we're going to see slightly different variables. That normalize method has done all the trigonometry work for us. So what it now says that if we want to follow that path, then we need to move along by this many pixels and move down by this many pixels. We can now use that to move the enemy. So we'll remove these brackets and we'll say self.pause is increased by that variable normalized. And lastly, to be able to actually position the rectangle and move it around, we need to say self.rect.center is equal to self.pause. So just what we did when we first initialized it, since the self.pause variable is updated, the rectangle center also needs to be updated. Run it again, and now we can see the enemy is now following that path. And now since the enemies are going to be different throughout this game, some of them will move faster than others. So what I would like to do is add a variable here called self.speed. For now, I'm just going to set it to a fixed value, but later on this is going to change depending on the enemy type. And we can use this speed variable and multiply it here, self.speed. So now the enemy position is going to be updated a little bit faster based on this variable. If we test it out again, you can see he moves over a bit faster. Now we've got the enemy moving along this line, but what happens when he gets to the end of that waypoint? We can see he kind of starts just oscillating around it. Rather than moving on to the next one, he just seems to bob all over the place. What's happening is that he overshoots it slightly, and then in the next iteration he looks backwards, moves back again, overshoots it again, and essentially just keeps going back and forth, never really reaching this waypoint. The reason that happens is because the distance between the player's position and that waypoint is less than the actual movement speed that we end up with here. So actually what we need to do is every step that the enemy moves, he needs to look at how much room or how much distance is left until he gets to that target waypoint. And that way we can adjust the movement so that it doesn't get overshot. So after we calculate the movement and before we update the position, we're actually going to separate these out because we need to add another little section here. And this will say calculate distance to target. Now this again could be done with some simple trigonometry, but because we're using vector 2, there is already a method that will help us with this. I can say the distance is equal to self.movement, which is that vector between the current point and the target point, dot length. Now let's actually test this out. So we'll print this distance variable. We run this again, and as the enemy moves, you can see it's quickly dropping down. And eventually, when he gets to that waypoint, you can see it's kind of hovering around. It never reaches 0, so it's always just either side of the waypoint. Well, now we can do a little check using this distance variable. Add a comment to say check if remaining distance is greater than the enemy speed. So if dist is greater than or equal to self.speed, well actually that means that there's enough distance remaining. So in this iteration, when the enemy moves, they're not going to overshoot the target. So we can do what we had before. We can move this section back up here into this if statement. Otherwise, so we'll have an else in here. If that isn't the case, then we don't want to move by the full speed amount. So we do take this line, copy it back down, but now instead of moving it and multiplying it by self.speed, we actually just limit it to the distance. And this means that once the enemy gets close to the waypoint, if it's only a little bit remaining to the waypoint, then it's only going to move by that little bit. And the result is that he's going to land exactly on top of the waypoint. Let's test this out and see what happens. So the enemy moves along like before, gets to the end, and now we throw an error. Now the error is happening in this new line that we've added. And the reason that's happening is that the enemy has reached the target. So now distance between the target and the position is 0. So that means that this variable, self.movement, is 0, and we can't normalize a 0 vector. That's what this error is telling us. But of course, if the enemy has reached that target, that means that we need to set a new target. We need to move to the next waypoint after that. So just under this line, we will say self.target_waypoint is increased by 1. If we run this again, we now see the enemy moving along, and at this point, it should move to the next waypoint. Now we get the same problem on the next waypoint instead. So why does it happen there? There will be some instances where the enemy arrives exactly on top of the waypoint using its own self.speed. So this section here never comes into it until the enemy is already there. And that means that the movement is already 0, and we try to normalize it, leading to this error. So we need to add another if statement here. We'll say if dist is not equal to 0, then we do this. So it's basically just a little error check here to catch this potential risk. If we run this again, the enemy now follows to the first waypoint, up to the second, and then continues on to the next one. So now we're getting the enemy to follow all of those waypoints correctly. Of course, when we get to the end of the path, we are still getting this error, but that's simply because we haven't accounted for that yet. So we need to go back into the enemy class and make sure that there are enough waypoints remaining in that list. And we will do that within this first section up here, where we work out where our target is. Before we do that, we'll say if self.target_waypoint is less than the length of that waypoint's list, then we can indent this section in here. So essentially this is saying that as long as we actually have those waypoints available within the waypoints list, well, then that's fine. We'll set a new target and we'll calculate the movement variable based off that. But if that's not the case, well, that means that we've arrived at the destination. So enemy has reached the end of the path. And at this point, we just want to delete the enemy. To do that, we just say self.kill. This is another method that we've inherited from the sprite class up here. So it's going to automatically remove this instance from the sprite group. Now we can run this again. The enemy follows the waypoint, go to the first one, second one, and when it gets to the end, it disappears. Now at this point, we've got most of this working. The only thing that I would like to do is actually have the enemy rotate to face the correct way. So right now, it's just always pointing to the right, but I'd like it to follow the lines as it goes. So to do that, we go back into the enemy class, and there may be a vector method for this, but I'm just going to use the math module. So we'll import math, and then we'll use a little bit of trigonometry to work out that angle. So I'll define a new method down here, and I'll call it rotate. So we'll say def rotate, and we pass in the argument of self. So we'll add a comment to say calculate distance to next waypoint. So it's actually similar to what I've done previously, but I'm not using vectors anymore. So I'll just say dist is equal to self.target minus self.pause. Then we'll add a comment here to say use distance to calculate angle. And this is where we use that math module to calculate the angle. So we'll say self.angle is equal to, and I'll set this up in steps. So first of all, we'll say math.atan2, and here we need to pass the y distance and the x distance. So we need to break this down into its two individual components. So for the y distance, we'll say dist at index 1, and for the x, it's dist at index 0. Now, because the y coordinate is flipped in Pygame, it starts from top and goes down to the bottom, we need to invert this by saying minus. Now, this will give us an answer in radians. We need to convert that into degrees. So we'll say math.degrees and then wrap all of that in brackets. Now that we've got the angle worked out, we can rotate the image. But if we keep rotating the same image over and over, then over time, we're going to lose quality in the image. So what we actually have to do is keep the original image and then rotate that image every time. So as well as this self.image variable, we'll say self.original image is equal to image. I will also define a starting angle. So we'll say self.angle is equal to 0. And I can use that angle in the original image to update this self.image variable. We'll remove that and we'll say pg.transform.rotate. And what we're rotating is the original image, and we're rotating it by that angle of self.angle. And now we will run this section of code every time we want to rotate the image. So I can actually just copy this from here and move it down into our rotate method. So just underneath where we've worked out the angle, I'll add a comment to say rotate image and update rectangle. Then I can paste that in, and it's going to do the same thing as before, but now I have a new angle, so it's going to have a new image. We'll take a rectangle from that and we'll reposition it at this self.pos variable. We can actually remove that from this move method from above, just to tidy things up. And of course, with this new method defined, we need to actually call it somewhere. Well, we've got this update method here, and that's what I'm going to house all the remaining methods inside of. So I'll say self.rotate. So that means that when we call this update method from the game loop, it will follow on and call these by itself. So we go back in here, and now we run this again, and you can see that this time the enemy rotates and it faces the target that it's moving towards. Now that the enemy waypoints are working, I'd like to load in a game map. For this, I'm going to use a free tile map. I found this tile map online from Kenny, and I'm going to put up a link to the original creators page. I'm going to be using the grass and dirt tiles, but you could use any of these if you'd like to change the look of the game. The way the tile map works is that the image is split into these individual squares or tiles. You can then arrange these tiles in any pattern you like to create large maps with only a few images. I've previously used my own level editors in my own games, but for this project I'm going to use a free editor called Tiled. This is the editor here. I'm not going to go into all the detail of how to use it, as it would take too long, but if you do want to see a detailed tutorial on Tiled, then let me know in the comments and I can make a separate video on that. This is the level that I've created for this game using the tiles from the asset pack. Before we go ahead and load this into the game, I want to draw your attention to a couple of properties that are important later on. So we've got width and height here of 15. What that's referring to is the number of squares, the number of tiles in each axis. So I've got 15 going left to right and 15 going up and down. Additionally, we have the tile width in pixels and the tile height. Both of these are set to 48. We don't have to worry about these just now, but we will come back to them later on. To get this tile map into our game, I can just export it as an image. There's an option down here to export as image, and that will allow me to save this as a PNG file straight into my game folder. Back here in the code, we can go into that levels folder, and we can see the PNG file right there. And there's the map. So let's load that image in and use it for our level. In this section, under load images, I'm going to load my map underscore image. In fact, I'm just going to separate these with other comments. So this will be the map, and this one will be enemies. So map underscore image is equal to pg.image.load, and the folder is levels/level.png. And lastly, we'll just say convert alpha. Next, we want to set up our game world, and I'm going to do this as a class. So I've created a file here, world.py, so you'll need to make sure you create the same file and put it in the same folder with the rest of your Python files. And we'll begin this one the same way as the others. Import Pygame as PG, and then we'll create class world. And here we don't need any inheritance from the sprite class because we don't need that functionality. So we'll create the constructor, which is our init method, pass the argument of self and map underscore image. Then we just assign that image to self.image. And for now, that's the constructor done. So we will just create a draw method. We'll say self and surface. And here all we'll do is call surface.blit. What is it that we're blitting? Well, it's self.image, and the coordinates are going to be 0, 0. So this doesn't change. The map will always be drawn from the top left corner of our game window. With that done, we can go back into the main file and create an instance of this world. But first of all, we need to make sure that we import this class. So just like we did with the enemy, we'll say from world import world with a capital W. Now I can go down here, just above where I'm creating my groups, and I will add a section to say create world. So world is an instance of the world class, and what we pass into here, the only thing right now is the map image. now that this instance is created, we should be able to call the draw method and show it up on the screen. So just after we fill the background down here, we're going to say draw level, and we'll call world.draw onto the screen. If I run this now just to test it, we can see the map coming up. So we've still got the waypoint and the enemy moving around, but in the background you can see part of the map. Now the whole thing doesn't fit here. And the reason for that is if we go back into our constants, we arbitrarily define these as 500 by 500 pixels. So clearly we need to resize these. We need to work out how big our map actually is. Well, this is where we go back to tiled and those attributes that I mentioned earlier. So we have 15 rows and columns, and each of the tiles is 48 pixels by 48 pixels. So I can create these variables within this section here. I'll move this down and I'll say that I have 15 rows and I have 15 columns. And each of my tiles, tile underscore size, is 48 pixels wide. And now, rather than manually defining the screen width and height, I can say that it's tile size multiplied by the number of columns, and the height is tile size multiplied by the number of rows. And if we go back and test this, we should be able to see that the window is now the correct size and the entire map fits in. Now from this map, you should be able to see the path that I intended for the enemies. So we start up here and they follow all this path all along and exit out here. Now that means that my waypoints list is going to have a lot more information in it. I could do this manually. I could simply update all of these points one by one, but there's an easy way of doing this using tiled. There's a feature here called polygons, and it allows you to create a set of individual points that are all connected to each other. Now I've already done this and I've set up my waypoints here. And if I change the draw order, you'll be able to see my path that I've created. And this path is quite easy to modify. So for example, I can use this tool here to edit the polygon. And if I just click on the polygon, I can move the points around. So you can quite easily change the waypoints around as you wish. The tile map and the waypoints are on two separate layers within tiled. So I can interact with them independently. I can turn off the visibility on one or the other. But more importantly, when I export this data, I'll be able to access them separately. There are a few ways of getting this data out of tiled and into Pygame. And it all comes down to how we export it. So if I choose export as, then there's a whole bunch of different formats that I can use here. The one I've decided to go with is JSON, and I've previously exported it here as a TMJ file. So let's have a look at the contents of that and see what actually comes out from this export. So back here within my code, if I go into the levels folder and open up level.tmj, this is the JSON data from that level map. At first, this is going to look really confusing, but if we scroll down, there's a section that's going to look recognizable, and it's this bit here. We have a set of X and Y coordinates, and this is referring back to that polygon that I drew earlier. These are my waypoints. And in fact, if I scroll up a little bit, we'll be able to see the name of them. So the name here is waypoints, and that's exactly how I've named it here. So what we need to do now is parse this data here, work through the JSON file, and just extract these X and Y coordinates. And before we do any of that, we need to import the JSON module. So we go right up to the top and we import JSON. And now we need to load that file into our game. We go down here, just underneath where we've loaded the images, and I'll add a comment here to say load JSON data for level. We'll use a context manager here. We'll say with open, and then we'll pass in the location of that file. It's in the same folder. It's in levels/level.tmj. And at the end, we add as file, and we'll save this to a variable called world data. So world data is equal to json.load file. So let's just print this out and see what the output looks like. We'll print world_data. Now when I run this, we can see down here, we've ended up with all of that information from the JSON file output into our Pygame. So now we should be able to parse through this information and look for the data that we need for these waypoints. We'll get rid of this print statement again, and then we will take this world data and we'll pass it into our world class. So whenever we create the world instance, we will pass this data into it. We'll change that as the first argument. And then of course on the world, we need to make sure that we receive this argument in here. So we'll add the data argument. Then self.level_data is assigned to that variable. Next, we need to start processing this, working our way through it and getting to the waypoint data that we need. So I'm going to create a new method here, and I will call it process underscore data. It doesn't need any arguments because it will just take whatever the instance already has. And we'll add a comment to say look through data to extract relevant info. So let's go back over to this JSON file and let's take a look at the structure. If we go back over to tiled for a second, our waypoints and a tile map are both under layers. So each of these is a separate layer. And if we have a look at our JSON file, there is a section here called layers, which contains a list. So we need to get into this layers list. To access this list, we go into self.level underscore data and we pass it into the index. So we just pass layers in here. And that's going to get us access into this layers list. And now we need to iterate through each of the layers. So for that, we use a for loop. We'll say for layer in this layers list. We now need to see which layer it is we're looking for. So each of the layers, if we go a little bit further in, it has some properties. The name is what we're looking for at the moment. So the tile map has the name tile map, but our waypoints have the name waypoints. So that's the one that we're going to look for. So we go a little bit further here. Once we iterate through the layers, we want to check if that layer's name attribute is equal to waypoints. And at this point, let's test this out. So we'll say print layer. So if this happens, then we're going to print this out. Now, before we can run this, we need to call this process data method from our main.py file. Just after we create the world instance, we'll say world.process data. And if I run this again, I get a little output of information down here. But now you can see we're not getting as much as before. And the important thing here is that it's picking up the waypoints layer. So let's drill down a little bit further. We can pretty much ignore everything else. We know that we're now in this layer, and this layer has an object list. Remember, we're just trying to get down to this polyline section here. We want to get these X and Y coordinates. So we're slowly working our way down one by one. So now we want to look through the objects list, and we want to look for this polyline. As before, we just iterate through it. I'm going to get rid of this print statement, and I'll say for obj in layer, and we're looking for objects. Iterate through each of those objects and then extract that polyline data. So we'll save that into a variable called waypoint underscore data, and that's going to be obj index polyline. We'll go back here one last time. So this is our objects that we're iterating through, this list here, and this is the polyline data. Now the polyline itself is a list, but right now we don't need to go any further because we're just going to take the contents of that list, and that's going to give us all of the X and Y coordinates. And let's just print this out to see what we end up with. So we'll print out waypoints data, go back here and run this again. And if I just expand this a little bit, now you see we're not getting anywhere near as much. We've just restricted it to that polygon data. Now we've got the X and Y coordinates for each bit. But we can't use this just as it is yet, because each of these entries is a dictionary. So we have a list that has a whole bunch of dictionaries inside it, and those dictionaries have X and Y keys with their own values. So we need a further level of processing now. So we'll just get rid of this and go back into our world class. And now, just to keep things tidy, I'm going to create a separate method. And this one is going to be called process waypoints. So this will take self and it will take data. This will be the data that we pass into this. And what data do we pass? Well, it's this waypoint data that we've extracted. So now rather than printing it out, we're going to get rid of that and we'll call that function. We'll say self.process waypoints and we pass the waypoint data into it. So the processing that we have to do now is again just to iterate through this list so that we can extract each of the values independently. I will start this with a comment to say iterate through waypoints to extract individual sets of X and Y coordinates. And we will use a for loop for that. I will say for point in data. And for now, let's just print each point out just to see what we're working with. Run this again. And now you can see they're structured much better. So now we're working through each of those one by one. The next step is to extract the X and the Y value from each of these points. We go back into here again, and we'll just save them to temporary variables. We'll say temp underscore X is equal to point.get, and what is it we want? It's the X value. So this is going to go into our point, which is this individual dictionary one by one, and it will get the value of the X key. So to get the Y value, we need to pass the Y key, and we'll do the same thing here. We'll copy this down, change from X to Y, and that will give us both of the points. So we can change this now to print out a different statement. So we'll take our temp underscore X and our temp underscore Y. We'll run this, and now you see it looks very similar to before, but now instead of being a dictionary, we just have these tuples for each waypoint. We have an X and a Y coordinate for each one. Now we just need to gather them all up together and store them inside one list. In this constructor, I'm going to add another variable called self.waypoints, and I will set it to an empty list. And now at the end here, after each iteration of the for loop, I will update that waypoints list. So I will use append, and I will add a tuple of temp X and temp Y. I can now compare this to the original waypoints list that we manually created. So let's just print out waypoints, and we'll see what that looks like. So we have this list with tuple values inside it. And now we can use the one from the world class. So we'll say world.waypoints. Run it again, and it looks the same, but now I just have a lot more values, and they're all taken from that tiled file. Now we can remove this waypoints list that was created manually. So we'll delete that, and into the enemy class, we pass in the one that's attached to our world instance. And also down here in the game loop where we're drawing that path, we need to make sure we do the same thing. So if we run this again, you can now see the path follows what I've drawn previously in tiled, and the enemy walks along that path as well. From this point on, we don't really need to draw those waypoints anymore. So I'm going to delete this section, and now it looks a lot nicer, and it just looks like the enemy is following this dirt path. Now we've got the enemies working as well as the map loaded, so the next thing to do is add in turrets. We will create this in another file, so I've already set up this turret.py file, which you'll need to create and put it in the same folder as the rest of your code. And we'll start this as normal, import Pygame as PG, and then create the turret class. This turret class is also going to inherit from the sprite class. So the same as the enemies, I'm going to add this pg.sprite.sprite in the brackets. Then I'll create my constructor, which is the init method, and I will pass self, then the image that we will use for the turrets, and the pause variable to position them. Then in this constructor, because I'm adding inheritance, I need to call the sprite class's init method. We'll say pg.sprite.sprite, and then call the init method here, and pass self as the argument. And now we can assign those arguments into these variables. I'll say self.image is equal to image, then self.rect is going to be derived from this image, so we use the get_rect method, and lastly self.rect.center is going to be at this variable pause. So now all of these arguments are saved as these variables. Now we go back into our main file and make sure that we import this turret class. I'll say from turret import turret with a capital T. Next we'll go down here and load in the image. I'll add a comment to say individual turret image for mouse cursor. Later down the line we will use sprite sheets, but for now I just need one still image of the turret. So we'll say cursor turret is equal to pg.image.load, and it's going to be in assets images turrets, and it's cursor underscore turret.png, and then we add convert alpha in the end. So far this is very similar to how we set up the enemies, and likewise I'm going to create a group for the turrets. I will say turret underscore group is equal, in fact I'll just copy this down from above, so I just need this section here that it's equal to pg.sprite.group. Now that all of that is set up, let's actually create turrets. This is going to be done by clicking. So we go into the event handler and we look for a mouse click event. So I'm going to do it underneath this quit event. I will add a comment to say mouse click, and we'll check in the same way as the quit event. We'll say if event type is equal to, and the one we're looking for is pg.mouse button down. So this has to be all in caps. But I don't want this to be just any mouse button, this has to be a left click. So I'll add a second check, which is event.button is equal to button number 1, which is the left mouse button. So if those conditions are met, then we can create a turret. To create a turret, we'll just say turret is equal to the turret class, and then we pass in the arguments. The arguments it needs are the image and the position. Well, the image is easy enough. We've loaded that in. That is the cursor turret. But then for the position, we're going to be positioning these turrets at the location of the mouse. So first of all, I need to get the mouse coordinates. So here I'm going to say mouse underscore pause is equal to pg.mouse.get underscore pause. So this will return the x and y coordinates of the mouse, and I can then pass that in as an argument here, mouse pause. Once the instance is created, we need to add it into the group. So we'll say turret group dot add the individual turret. And lastly, to be able to actually see them, we need to call the draw method on that group. So I'll say turret group dot draw onto the screen. Now if I click somewhere, you can see I can place down these turrets. Now we can develop this a little bit further. For a start, although this is all working fine, eventually this game window is going to get a little bit bigger because I'm going to have a menu on the right hand side. I don't want to be able to click there and place turrets. I only want to be able to restrict that to this actual map. So I need to add a little check in here. Once we've taken the mouse position and we've worked out the coordinates, I'll add a comment to say check if mouse is on the game area. So I need to check mouse pause 0, which is the x coordinate, and I need to make sure that that is less than the screen width. And likewise, I need to check that the mouse position at index 1, which is the y coordinate, is less than the screen height. So if those conditions are met, then that means that the mouse is only on top of the tile map. If we go outside of the game area and try and click on the menu area, then there's not going to be any turrets placed. The next thing that I want to address is that this is a tile game, but right now I can click pretty much anywhere and just stack these turrets right next to each other. What I want to be able to do is only put them into individual tiles. So essentially I need to split the game up into a grid, just like it is in a tile map, and only allow the turrets to be placed in one point on that grid, not right next to each other like this. This is going to require a few more checks, and I don't want to fill my event handler with all those checks. So what I will actually do here is move this stuff into its own function. So I'm going to cut this out of here, and I will call a function called create turret, and I will pass the mouse position into it. Now I can scroll up a little bit before my main game loop, and let's just do it up here, just above creating the world. I'm going to define this function. So create underscore turret, it takes the argument of mouse position, and I will paste what I just cut out back into here. So this should run just as it did before. I'm able to place the turrets just in the same way. But now I can expand this function a little bit. So I have my mouse position, which means I have the x and y coordinates of that. I can now divide that by my tile size to turn it back into the individual grid squares. So let's say mouse tile x is equal to mouse position at index 0, so the x coordinate, and we'll do floor division divided by the tile size. Then we'll repeat this for the y coordinate. So I'll just replace this with y, and I'll replace this index with 1. Now instead of passing the mouse position, we can pass those two individual variables one by one. So we'll pass in the tile x variable and then a tile y variable. We go back into the turret to update that, so we'll replace pause with tile x and tile y. Then we will assign those arguments to self variables. So self tile x is going to be tile x, and we'll do the same for the y coordinate. And then here I will need to basically do the reverse of what I've just done. So I'll add a comment to say calculate center coordinates. So I take those self.tile variables, multiply them back by the tile size to work out the x and y coordinates. So we'll say that self x is equal to self.tilex multiplied by my tile size variable. Now I need to import the constants module into here. So at the top I'm going to say import constants as C. So now I'll be able to access this tile size variable. I can do the same thing for the y variable. And now, because I don't have this pause variable anymore, I'm going to replace that with the two individual self.x and self.y coordinates. Okay, so let's see what this actually does. Now every time I click, you notice that I'm not able to put them wherever I want. So now they are arranging themselves into a grid. They don't seem to be positioning very well. There is still something else that we need to work out, but you can see now that the placement of these is now based on a grid. The reason they're not being positioned in the center of each grid point is because when I'm multiplying these values back out again, I'm getting the edges. So I'm getting the left edge with this x coordinate, and I'm getting the top edge with this y coordinate. I need to add another half a tile size to each of these, which will allow me to put this exactly in the center. So to do that, I'll just need to add brackets around these, add on a half, and close the brackets before I multiply. So now, if I was to test this again, I should end up with each of the turrets appearing right in the center of each of its grid point. You may have noticed though, there's another little issue that we need to address. So although now all of these turrets are lining up nicely based on grid positions, I'm able to fill them into this green space where they should go, but I'm also able to put them on the dirt path where the enemies walk. And obviously I don't want to be able to put them there. I want that area to be restricted and only place turrets on all of these green tiles. But to be able to tell the difference between the dirt path and the grass tiles, we need to once again go back into our level data and to this JSON file. Because this first layer here that contains the data, well, that's actually our tile map. And I know from working with this tile map that the number 7 corresponds to the grass tiles. In fact, you can see as I've highlighted them here, that the outline is all the grass tiles, number 7. So what I need to do is before I place down a turret, I need to check if the value of that tile is a 7 or not. If it is, then that's okay. But if not, then I can't place a turret there. In the previous section, we looked at how to process this JSON file. So actually within our world class, we already have this process data function. We just need to add to it a little bit. This first section here iterates through the layers and it looks at them one by one. So down here, we're checking for the waypoint layer. But for the tile map, I need a different one. I need the one that says tile map. So I'm going to add another check here. So before we do that check, we'll say if layer name is equal to, and this time is the tile map. If it is, then we just need to take this data variable because it's already a list that contains all the tile map data. So we can just extract that straight into a variable. We'll create an empty list up here, say self.tile_map is equal to an empty list, and then we can assign to it here. We can say that that self.tilemap is equal to the layer that we've just extracted from the JSON file at index data. But now we don't want to have two if statements in a row, so we'll change this one to an elif. Now let's take a look and see what this data actually looks like. So once I process it, I'm going to print out the tile map. And when we run this, we will see the output down here. In the JSON file, it kind of looked like it was arranged into a grid, so you can see the individual rows and columns. But you notice that at the end of it, it's just a comma. It doesn't close a list and then create a new list underneath. So in reality, from here to here, it's just one big long list. I can't differentiate between rows and columns here. So for example here, I can see that this is row 2. But in this data list, there aren't any rows. This is just a sequential value, a sequential index within the list that comes after this one. So I'm going to have to work out my rows and columns and then manually use those to work out the sequential order of that point. So we'll need to make a couple of changes into this create turret function. I'm going to add a comment here to say calculate the sequential number of the tile, and we'll say mouse tile num is equal to mouse underscore tile y multiplied by c.colls, because I know how many columns are in each of my rows, and onto that I will add mouse tile x. And now that I know which index value it is that I'm clicking on, I can compare that against this level. So I can check, is it a 7 or is it not? So we'll add a comment here to say check if that tile is grass, and that tile data is stored in our world class. It's this tile map variable. So we'll say if world.tile_map at index value mouse tile number. If that's equal to a 7, then that means that we've clicked on grass. So that means we can put a turret down. And I'm just going to move this stuff up here and add more indentation to it. I don't need an else, because if I'm clicking on something that's not grass, then I simply do nothing. So if I test this now, I can still create my turrets down here on the grass, but as soon as I click on the dirt, I can't do it anymore. Even on the edges of the dirt, I have to go outside and click on the actual green space around it. Now the next issue that I want to tackle isn't actually very clearly obvious. So as I'm clicking here, you can see that I'm just creating a single turret. I'm not adding anything else, but we can't really tell what's going on underneath that. What I would like to do in here is just temporarily print the length of that group. So we'll print out our turret group. And now as soon as I click, it says group with 1 sprite. If I click here, I've got 2 sprites, 3 sprites, 4, and so on. But if I just click on the same point again, it still keeps going up. So although we can't see them individually because they're drawn right on top of each other, I'm actually adding turrets all in the same location. I want to be able to limit that so that I can only add a turret if the space is free. So that means that I need a secondary check here. We'll get rid of this print statement. And before we put the turrets down, first of all, we've checked that yes, it's grass. So that means that we can put a turret down. But then we need to check that there's not already a turret there. So a comment to say, check that there isn't already a turret there. And I'll begin this by defining a variable called space is free. I'll set this to true. So we begin with the assumption that that space is indeed free. And then we're going to iterate through all of the turrets that we've created. So for turret in turret group, we iterate through each one and then we check the position of that turret. So if there's any turrets that are positioned at the mouse, then that means that that space is already taken. We'll say if, and then we will combine the mouse tile X and Y into a tuple. So mouse tile X, mouse tile Y. If that tuple is equal to an equivalent tuple from the turrets, so turret dot tile underscore X, then turret dot tile underscore Y, then that space is free variable becomes false, because that means that there is a turret already there. And then all we do, we'll add a comment here to say if it is a free space, then create turret. And I just need to add an if statement here. So if space is free is equal to true, then we can put down a turret. Otherwise we do nothing. To test this out, let's just go down to the main game loop and just anywhere, it doesn't really matter. I'm going to print out that turret group. So when I run this, I'm getting 0 sprites. So there's 1, 2, 3, 4, 5. But if I keep clicking on the location of the existing turrets, nothing happens. I can't put down any more turrets because it detects that there's one already there. Now I can get rid of this turret group statement. And the only thing I would like to tidy up here is the variable naming. Because I've got this for loop here where I'm iterating through the turret group and I'm using turret as my statement, I'm going to change this down here to new turret. And when I add it to the group, that's also the new turret. Let's just double check that everything works, and it seems to be working fine. The next thing that I want to add is a panel on the side of the game that will add all the buttons. So to do that, first of all, I need to increase the width of my game window. If I go back into my constants file, I've already got my screen width and height defined. In addition to those, I'll create another variable called side underscore panel, and I will set this to 300 pixels. I'm not going to change the width and height because that's just based on the size of my map. Instead, I'm going to go back into the main file where we create the game window, and I will just add it onto the width here. So I will add that c.side underscore panel. So if I run this again, I now have a bigger window. Now we can populate that window with some buttons. So before we create them, I'm going to load in a couple of button images. I will add a comment up here to separate them to say buttons. And the first one will be the by turret image. So this will be pg.image.load, and then we'll have a look at where that one is. So it's inside assets, images, and then buttons. So there's a whole bunch of buttons in here. We'll say assets, images, buttons, and the one I need for now is by underscore turret.png. And as always, we just need to convert at the end. So with that one loaded, let's load in the cancel button. We'll just change this to cancel and change the name to cancel PNG. Now I can create the actual button class. So I've created this empty button.py file. So just like all the rest of them, they're all housed in the same folder altogether. And we'll begin by importing Pygame as PG. Then I'll create my class of button. It doesn't need to take anything inside the brackets here. Next, I'll create a constructor. So I'll say def init. And the only arguments I need for now are the X and Y coordinates and the image that we're going to use. Now I can assign these to self. We'll say self.image is image. Self.rect is then derived from that image. So just like we've done before, we use the get_rect function, then self.rect.top left. So we'll position it based on the X and Y coordinates, and that will be the top left corner of the button. There's a few more things we'll add to this, but for now that's all that the constructor needs. Next, we'll create the draw method, and this needs to take the argument of self and the surface. Now, there are a few steps to working with buttons. First of all, we need to get mouse position. Then we're going to need to check mouse over and clicked conditions. And lastly, we're going to need to draw button on screen. So I've just kind of laid out the structure using comments for now, and now we can start filling it in with code. Well, to get the mouse position, we're already familiar with that one because we did this previously. So it's pg.mouse.get_pos. That will give me the X and Y coordinates of the mouse. And then I need to check whether that mouse is hovering over the button. Well, the button has a rectangle, so I can simply check for a collision. We'll say if self.rect.collide point, which will check for collision between the rectangle and a single point of X and Y coordinates, and we pass in the mouse coordinates. Well, if that's met, then that means that the mouse is currently hovering over the button. Then the next check is to see if it's being clicked. We'll say if pg.mouse.get_pressed, and we pass in the index 0 because we're looking for a left click only. If that's the case, then we know that we've clicked on the mouse. And for now, I'm just going to put pass in here, so we'll come back and fill this in a second. And lastly, we just need to draw this button. So we'll say surface.blit, self.image, and self.rect. And that created the button class. So we'll go back into the main file, and first of all, we need to import that class. We'll say from button, import button with a capital B, and then we can start creating instances of this. We'll go all the way down to where the game loop begins, and just above that, where we're creating the groups and so on, I'll say create buttons. So the turret_button, this will be for creating new turrets, is an instance of the button class. Now we need to add in the coordinates here. So I've based this on screen width because that's the width of our playing area, the map. So from that, if I add 30 pixels, then we're going to move just inside of that new panel on the right hand side. The Y coordinate is 120, and the image is the by_turret image. Now I can copy this down and create a second button, which is going to be the cancel button. So the coordinates are going to be 50 on the X, then 180 on the Y, and I just need to change the image to cancel image. Okay, let's just test this and make sure there's no errors. Okay, so everything's loading in fine. The images are coming in and we create the instances. And now we can start calling the draw methods for these buttons. But first, I just want to tidy up this while loop a little bit. So I want to create separate sections. I'll do that using these comment blocks. So just after the clock tick, I'm going to paste in this bit to say updating section. And then below that, I'll say drawing section. And then I'll just move all these things around. So this is all correct. This falls into the draw section, but this needs to move from here. So I'm going to cut this out and put it up into the updating section. Now I can go down here underneath all of these draw methods and add a comment to say draw buttons. So the first one is a button for placing turrets. And this one was my turret_button. So I'll just call the draw method and I'll pass the screen as the drawing surface. And then underneath that, I'm also going to call my cancel button. So it's cancel_button.draw onto the screen. Now I'm going to move these around, so that's why I've not added a comment for this one yet. So I'll just run this and test it to see everything is working fine. I've got the buttons coming up. I can't click on them yet, but we're going to do that next. If we go back into the button class, all we need to do here is add in a variable that's going to detect whether the button has been clicked. So at the very beginning of the draw method, I will create a variable called action and I will set it to false. So by default, this is always going to return a false value. But then in here, where I've got this pass, I'm now going to change this to update the action to true. This means that if we do click on the button, then this variable becomes true. And lastly, we need to return that variable back out of the function. So we go to the bottom here and we'll say return action. Now, because this function has a return, when I call this draw function, I can actually check what it comes back with. So for example, this can now have an if statement at the beginning. So if that is true, i.e. that action variable becomes true, we can just print something out. We can say new turret. And likewise, if the cancel button is drawn or clicked on, then that will return true, and I can say print cancel. So if we run this now, that one says new turret and that one says cancel. So that's working correctly, but you notice that although I click it once, it seems to return it many times over. We obviously don't want that in some cases. So some of the buttons will need just a single click, while others will need to be a click and hold kind of button. So first of all, we're going to make all of the buttons single click, and then we'll add the click and hold option. To make it single click, we simply need to add another trigger variable here. So we'll say self.clicked is equal to false. This is inside our constructor. So by default, as soon as the button is created, this variable is set to false. Then whenever we do click the button, as well as setting the action to true, we also set self.clicked to true. But once that happens, once this has been clicked and set to true, we need to make sure that this can't then happen again. So that means that within here, once we've checked that we've hovered over the button, we also need to add a second check to the click. So if it's been clicked and self.clicked is false, then it's okay to click on this button. But if self.click has been set to true, that means we've already clicked this button. So we don't want to run this code again. So let's try this again, and I'll click it once. Now if I keep clicking it, nothing happens. It doesn't detect it anymore. Same with cancel. I can click it once, but no more. So it's partially working. But what I now need to do is reset this variable as soon as I let go. So we'll add a second check here. It will say if pg.mouse.get_pressed index 0, which is the left mouse button. If that's now not clicked, if that's returning 0, then it means that we've clicked and we've let go. In that case, this trigger variable can be set back to false. So we'll go back in here, and now I can click over and over. If I click and hold, nothing happens, but I can release and then click again. So we've created these single click buttons. But I do want the option of being able to have a button that's click and hold. So let's go back into the button and just add a little bit more to it. Into the constructor, we'll add another variable, which is self.singleClick. And this is going to be dependent on the button. So we actually want to pass that in as an argument. So I'll add another argument, which is going to be a single click. So when I create a button, I pass either true or false as an argument at the end. And then I can assign it here. So this will be single click. Then we go down to where we're detecting the click, and just before this section here, so we'll detect action, we'll set that to true, and then underneath that I'll add a comment to say if button is a single click type, then set clicked to true. And underneath that we'll just say if self.singleClick. So basically if it is a single click button, then we set that variable, that trigger, to true. But if it's not a single click button, then this variable is irrelevant, because then we can just keep holding it down. So let's go back. Now, of course, I've added in this new argument at the top. So I need to make sure that when I create my instances of these two buttons, I pass that in. So let's just make them both different. The first one will make a single click button. So the turret button will pass true. The cancel button will pass false. Run this again. So the buy button, I can only click once. I can't click and hold. The cancel button, I can click and hold, and it'll just keep registering. So this gives me some differentiation between the two buttons. I only want them both to be single click, so I'll set this one to true as well. Now that we've got buttons working, the next thing I want to do is to actually use these buttons to allow me to place turrets, because right now I can just click on the screen and I'll place turrets, but I want that to only be possible when I've clicked this buy turret button. There's a few things that we'll need to do to make that happen. So first of all, I'm going to go back up above my game loop, and just before I start loading in my images, I'll have a section here which we'll see with a comment game variables. This will grow over time, but for now I only need one, which is placing underscore turrets. And I'll set that to false to begin with. So this is going to act as a trigger to determine if we're placing turrets or if we're not. Now I can go back into my game loop, and where I call these buttons, instead of printing out new turret, what I'm actually going to do is set that trigger to true. So as soon as I've clicked on that new turret button, this variable changes to true. And then I'll add a little comment here to say if placing turrets then show the cancel button as well, because I actually don't want this cancel button to be shown all the time. I want it to appear when we're placing turrets. So here we'll add an if statement to say if placing turrets is equal to true, and then I can indent this section and I can replace this print statement with a reset of that trigger. So if I click on the cancel button, then this trigger changes back to false. So let's just try this out. The button has disappeared. I click by turret, it reappears, click cancel, and it goes away again. But now I would like to also use this variable to determine whether or not I can place turrets on the screen. Because right now I can still click on them. Even though I haven't activated this by turret, I can still place turrets. Now that, if you remember, is actually handled through the event handler. So I have this section here that checks for this mouse button down event, and it checks if we've left click. And at the very end of it, we call this create turret function. Well, I can just put this inside another if statement. I can say if placing turrets is true, in that case, we can create a turret. But otherwise we're not going to. So now when I click, nothing happens. If I go into by turret, now I can place them. If I cancel, I can't place anymore. The last thing that I would like to do is make it so that once I've clicked on by turret, I can actually see this little turret that's attached to the mouse. So it will let me know visually that I'm in the mode for placing turrets. And to do that, we've already got the image loaded. It's that cursor turret image. So I go back up to where I've got this placing turrets true section, and I'll just expand it a little bit. I'll add a comment to say show cursor turret. So I'll create a rectangle from it first of all. I'll say cursor underscore rect is equal to cursor turret dot get underscore rect. So we'll get a rectangle from the image. Cursor position is the mouse position. So pg.mouse.get underscore pause. And then we position the rectangle at those coordinates. So we'll say that cursor rect dot center is equal to cursor pause. And now we can draw that image. We can say screen.plate cursor underscore turret and cursor rect. So we'll run this again. When I click on by turret, you can now see this little turret appears on the mouse. So this just lets me know visually that this is the mode that I'm in, and I can drop these turrets down. But as a little check, you notice that when we go over here, the turrets are still there. I don't actually want it to be shown when I leave the game area and I go into this menu sidebar. So we'll add another little if statement here before we blit it. We'll say if cursor position index 0, which is the x coordinate, is less than or equal to the screen width, well then it's okay to draw it, but otherwise we don't want to draw it. So I click by, there's no cursor. Move over here, and now I have a turret. Go back, and it's gone. And when I cancel, the whole thing goes away again. We will add in more buttons as the game progresses, but for now, this will allow us to proceed on to the next step. Now that we've got the turret placement working correctly, let's move on to the next stage and add animations. If I go into this assets folder and have a look at the turret images down here, you'll see that actually the turret images are in the sprite sheet. So what we've got here is every frame of the animation stacked up next to the one before it. So how do we use this sprite sheet for animating our turrets? Well, the approach here is first of all to load in the entire sprite sheet and then to extract each of the individual frames into their own image. Once we have all those frames, we can organize them together into a list. Then, by quickly cycling through each of the still images in that list, we can create the appearance of animation. We'll make a start by going into our main file and loading in the turret sprite sheet. This is where I load in that individual turret for the cursor, but before I do that, I will add another little comment to say turret sprite sheets. And for now, we're just going to load in one, even though you might have noticed that there's 4 different turret sprite sheets in here. We'll say turret underscore sheet is equal to, and then I'm just going to copy the code from below that we use for loading in the other turret. The only change here is to remove this section at the start and then call it turret underscore 1. Now, when we create an instance of the turret, instead of passing in the individual image, we can pass in that sprite sheet. So we go down to this create turret function, and down here is where we create an instance of the turret. So I'll replace that first argument, and now it's going to become turret underscore sheet. Now we can go into the turret class and update it to receive this sprite sheet instead of the image. So this changes to sprite underscore sheet. And I'm also going to expand this section a little bit, so I'm going to organize them first of all. I'll add a space here and a comment to say position variables. And then I'm going to break out the image and the rectangle below, because now we're going to be changing the image dynamically. I'll have a section here that says animation variables. And the first one is to save that sprite sheet into a self variable. So we'll say that self.spritesheet is equal to sprite sheet. Next, we will create this animation list. So we'll create a variable called animation_list. And this is where we're going to extract each individual frame from the sprite sheet and store it inside this list. So I'll create it as an empty list for now. To be able to extract the individual images from the sprite sheet, I'm going to create an additional method. We'll call this method load_images, and it doesn't need to take any arguments except for self. I will add a comment to explain what this method does, which is to extract images from sprite sheet. To be able to pick these images out of that sheet, we first of all need to know how big each of the images is. If we go back to the picture again, the way these sprite sheets are typically laid out is that each frame is in a perfect square, which means that if we know the height of the sprite sheet, we also know how wide each of the squares is going to be. That means that first of all, we need to work out the height of this image. We go back into our load images method, and we'll define a variable called size. We'll take that sprite sheet image, which will be self.spritesheet, and we will use the get_height method. Next, we will create a temporary animation list inside here. So we'll set this to an empty list as well. Now we can start iterating through each of the frames in that sprite sheet. I'll say for x in range, and this is where I need to know how many frames this sprite sheet actually has. If we go back to the image, we can see that it's got 8 frames. And I'm actually going to save that variable inside our constants file. I'll come down here and add another section to say turret constants. And the one we want for now is animation_steps, and this is equal to 8. Next, we go back into the turret class, and in this range, we will pass in c.animationSteps. With each iteration of this for loop, we want to extract one of those frames. We'll save it in a variable called temp_img, and this will be taken from self.spritesheet using the subsurface method. You can think of this subsurface as a small square that we can use to extract a section of the image. So the first 2 arguments are going to be the coordinate of the square, where it begins, so the top left coordinate. Well, the x coordinate is going to be changing because we move along to the right each frame. So we'll say x multiplied by size, and the y coordinate is always going to be 0 because we start at the top of the image. And then we need to define a width and height of this subsurface. Well, the width and height of each frame is going to be this size variable because it's going to be a square. I can pass size for both of those variables. And lastly, once I've extracted this temporary image, I can append it into our temporary animation list. So I'll say append temp_image. Once this for loop is completely finished, we're going to be left with this animation list. So I need to return this back out of this method. I'll say return animation list. Now I can go back up here where I initially defined this self animation list, and instead of creating it as just an empty list, I can actually call that method now. So I can say that it's equal to self.load_images. Now instead of an image for this turret, we've got a list of images. So when this turret is first created, how do we know what we should display? Well, the first image in this spreadsheet is the idle image, so it's kind of the way the turret begins. The rest of them are the shooting animation, but if we want to first create an instance of the turret, we should be using this image. And that image is going to be at index 0 in our list. We can go back into the turret class and continue with these animation variables. The next one is going to be self.frame_index. This is the index that is going to allow us to choose each of the frames in the animation. So to begin with, it's going to be 0. We begin with the very first image in that list. Now we can update this self.image section because we no longer have an individual image to assign this to. We have to go into our animation list, and from there we need to access the index of self.frameIndex. And the next 2 lines will stay the same. So this section I will add a comment to, and this will be the update image section. Now we should be able to test this and see if we can place these turrets. So I can place the turrets just as I did before, but the difference now is that we're placing them using the sprite sheet, and it's still giving us that first still image. Now we can have a look at how to animate the turret. We'll need to define a new constant variable here. And this one is going to be animation underscore delay. And I'll set this to 15 milliseconds. This variable is going to control the time in between each of the frames. So the longer the time, the slower the animation will go. This also means that we need to know when the turret was first created so that we know when the animation timer starts. We go down to this animation variables bit and I add another variable called self.update underscore time. And for this we'll say pg.time.get underscore ticks. This basically just takes a timestamp at the moment that this turret is created. And since this is a turret class, every turret will have its own timestamp. Now we can use these variables to play the actual animation. We'll go down here and define a new method. We'll say def play underscore animation. And it doesn't need any arguments, so we just pass self. To start with in the animation, we want to make sure that we update the image to the latest one. So I'm going to add a comment to say update image, and the code here is going to be the same as what I do when I first assign the image. So I can just copy that down here. Then we need to know if enough time has passed since the last frame was changed. So we'll add a comment here, check if enough time has passed since the last update. We'll take the current time by saying if pg.time.getTicks, so just what we did a second ago, and then we subtract our last update time. So the first time this runs, it's actually going to be the initial creation of the turret. If that is greater than this animation delay variable that we just created, so it's animation underscore delay, well that means that enough time has now passed and we can move on to the next frame. First we will change this variable update time so that we can reset the counter. So pg.time.get underscore ticks. And next we increase that frame index. So we'll increase this by 1, and this will allow it to move on to the next frame in that list. We can now put this inside an update method. So I'll create another method here called update, pass the argument of self, and I will just call self.play animation. And to call this method, we go back into the main loop and we'll look for the section where I've divided it into update and draw. And in this update section, just after I update the enemy groups, I will update the turret groups. So I'll say turret group.update. We can now run this and place down one turret. Now we get an error straight away. The error was intentional, but it happened a little bit too quickly. So we go back into constants just temporarily, and I'm going to increase this animation delay to 150. You don't need to do this, but it's just to demonstrate what's going on. So I'm going to place a turret down again, and then you can see it walking through its animation steps. So it does go frame by frame in slow motion, and then we get this error at the end. So if we track this error and we go back into the turret class, it's running from this play animation method, and it's actually triggering here. The error itself says that the list index is out of range. Well, that actually makes sense, because every time we move through this animation, we update the frame index by 1. Eventually though, we're going to get to a point where we've gone beyond the length of this list. So our turret animation has 8 frames in it, but eventually this will go on to the frame that doesn't exist. It will try to load that from the list and it will get this error. That means that what we need to do here is add an additional check, add a comment, so check if the animation has finished and reset to idle. We'll say if self.frameIndex, that variable that has just increased by 1, if that variable is greater than or equal to the length of that animation list, well then that means that we've come to the end of the animation, so we need to reset back to 0. I'll say self.frameIndex is equal to 0. If we go back and run this again, and I place down a turret, it runs through its animation and then it just repeats. So it goes over and over again. So we've now fixed that error and the turret is now in a loop. It's going very slowly though. So I'm going to go back to the constants and set this back to 15 as it should be. And if I run it again, it's going to shoot a lot faster. So that's more of a machine gun, but you can see it's running through the animation very quickly. The next thing I like to do is add a little bit of a cooldown, because we don't want this turret just firing constantly like this. The game would be far too easy. We go back into the turret class, and right at the beginning we'll create a couple more variables. The first one will be self.cooldown, and I'm going to manually enter this for now as 1500. As the game develops, we will call this in from somewhere else because it will depend on the type of turret, but for now I'll just define it manually in here. And then I also need to know the time of the last shot that was fired. So again, I'm just going to use pg.time.get_ticks. Now we go into the update method, and this section or this logic is actually going to be very similar to how we handle the animation. We'll say search for new target once turret has cooled down. And I just add another timer check. So I'll take the current time, so pg time.get_ticks. If that minus self.last shot, so the last time we fired, is greater than or cooldown, then that means that the turret has cooled down and it's ready to fire again. So we play that animation. But when the animation is fully finished, we need to record that that's finished and we now need to start the cooldown. The animation is complete in this section here, this if statement. We can just expand it a little bit to say record completed time and clear target so cooldown can begin. We'll say self.lastShot is equal to pg.time.get_ticks. If we run this again, we should now be able to place down a turret, it will fire, and then it will cool down and it will fire again. And notice that if I place a few different turrets, the time that I place them at is going to be different for each one, so they all fire at different intervals. The next thing I want to work on is adding a range to the turrets. We'll begin that by going into the turret class and adding a new variable at the top here. So just before the cooldown variable, I'll add another one which will be called self.range. And I'm going to manually define this to 90. So similar to cooldown, I'm manually entering them for now until we automate this later on. When the enemies come within this range of the turret will be able to fire at the enemies. But I want to be able to visualize what this range actually looks like. To do that, I'm going to come down here underneath where I set up my image, and I will create another image for the range. I will say create transparent circle showing range. Now this will be done in two stages. The first is to create a surface. I'll say that self.rangeImage is equal to pg.surface. The surface is going to be a square. So I'm going to take that self.range variable and multiply it by 2 because the range is a radius. And I'll do the same thing for the height. That creates my surface. I'm then going to fill that surface with a color black. So I'm going to pass in RGB values here of 0, 0, and 0. And then I will use that same color as the color key. So I'll say rangeImage.set_color key, and I will set this to black again. That will allow me to change the transparency of this image. Now I'm going to draw my circle on top of this surface. I'll say pg.draw.circle. The target surface is the range image. The color is going to be gray 100. Then I need the X and Y coordinates of the center, which will be my self.range, because again, this is a radius. And then lastly, the radius of the circle, well, that's also self.range. Now I'm going to set the transparency of the surface. I will say self.range_image.set_alpha. And I'm going to set this to 100. You can play around with this value to change the transparency of the image. And next, to allow me to position this, I will need to create a rectangle from it. I will say range_rect is equal to self.rangeImage.get_rect. Then we'll position the rectangle center. So we'll say rangeRect.center is going to be equal to the center of the turret rectangle. So self.rect.center. So now both of these are going to be positioned on top of each other. The current draw method is only going to draw self.image. It doesn't draw any other variables. That means that I need to create my own draw method. We'll go all the way to the bottom here and define a draw method. It will take the arguments self and surface. And then on the surface, I will blit the image of my self.rangeImage at self.rangeRect. If I now go into the main loop and I run this, and I try and place down a turret, it works just as it did before. It's not showing me that circle. So that means that I can't call this draw method that's down here, applying to my turrets. I can't call it anymore. This applies to the group, but because I've defined my own draw method in the class, I need to iterate through this group. So we replace this with for a turret in a turret group, and then for each individual turret, we call the draw method, and we pass in the screen. So now if I run it, I'm going to have the opposite problem. when I put this down, all that's being shown is that circular image. The turret isn't shown anymore. So that means that in here, I need to tell it to draw the turret as well. We'll say surface.blit, and it's self.image at self.rect. Okay, so let's try this again in the main game loop. And now as I click, I can drop down these turrets, and you can see this range showing me the circle in which it will shoot at the enemies. So as long as the enemy moves into the circle, then it'll be shot by the turret. I don't want that circle to always be shown though. I only want it to be shown when a turret has been selected. So we will add an additional variable to account for that. We'll come up here and we'll say self.selected is equal to false. So that means that each turret will start off in the not selected position. And then I can make this draw method, or rather this section of the draw method, conditional on that variable. I'll say if self.selected, well, if it is, then we can draw this range image. But now I need a way of actually setting this variable here to true somehow. Well, I'm going to do that within the main game loop. In here, we're going to need to track the selected turret. So before I even do that, I will create a new variable right at the top where I've got my game variable section. This will be selected_turret, and I will set that to none to begin with. Then we want to create a function that will allow us to select an individual turret. I've already got one up here for creating turrets, so just below it, I'm going to create another one. I will say def select_turret, and this is going to take the mouse_pause variable as an argument. Then the first section is just the same as the create turret. So I'll copy this down, and essentially we're taking that mouse position and converting it into a tile. Next, we want to check if there's a turret already at these positions. Well, we're doing that previously inside this function. So I can copy this out of here and paste this down and just correct the indentation. So what's happening is we're looking through each of the turrets inside the turret group, and then we're checking if our mouse coordinates match up with that turret. If they are, then we need to return that turret out of here. Now we just need to call this function from somewhere. I'm going to do that from this event handler, because down here we're already checking for mouse click events. So here we check for the mouse click, and then we're looking at whether we're placing turrets. So if we're placing turrets, then I don't want to be able to select an existing turret. But if we're not, then we should be okay. So I can add an else statement in here, and then I will assign a turret into my selected turret variable, which will be the output from the select turret function. Lastly, we just pass in this mouse position variable into it. And this will get us most of the way there, but remember, if we go back into the turret class draw method down here, that range is only going to be drawn when this self.selected variable is set to true. So we need a way of setting that to true for the turret that's been selected. Back here in the main game, we go up to our update section, and just below where we update the groups, I will add a comment to say highlight selected turret. And this is going to be determined by that variable. So if selected_turret, if there is a value in there and it's not none, then we're going to take that turret and we're going to set its selected variable to true. So if I test this out now and I place down a couple of turrets and then I go and click on them afterwards, they get highlighted, and now you can see this range outline. If I click on the next one, it does the same thing. So I can keep placing a bunch of turrets, and then I can select all of them, and I can see the range that the enemy would be fired on if they entered in here. The thing is though, I don't want to have all of the turrets shown up like that. So once I select one turret, if I click somewhere else, I want that selection to be cleared. Likewise, if I click on a different turret, I want the first one to be cleared and disappear. So we need another function for this. We'll go up to the top and we have our select turret function here. So just underneath this one, I will create another one, which will be clear_selection. It doesn't need to take any arguments. And all this is going to do is iterate through the turret group. We'll say for turret in turret group. And then one by one, we'll set turret.selected. We'll set that variable to false. So whenever we run this function, all of the turret's selected variables will change to false. And once again, to call this function, we go into the event handler. Anytime we've clicked the mouse and that click is inside of our game window, we want to clear the selection. I'll add a comment here to say clear selected turrets. So first of all, I'll overwrite that variable, selected turret. I'll set that back to none. And then I will run the function clear selection. Then if we test this out and I place a few turrets down, so if I click on this one and then I click somewhere else, it clears. Likewise, if I click on a turret and then I click on another one, it switches from that one to this one. Now that we have the turret's range working correctly, let's make them shoot at the enemies properly. To begin with, I'll go into the turret class and I'll create a new variable here, which will be self.target, and it will be set to none. This is going to track the target that the turret is aiming at. Then we can go down to just below our update method and create a new method. This one will be called pick_target. And the arguments that it will take is self as usual, and then it will take the enemy group. We will pass that in a second, but it will need to be able to know where all the enemies are so that they can pick a target from them. Next, I'll add a comment to say find an enemy to target. I'll define a couple of variables. So x_distance will be set to 0, and then y_distance will be the same. It'll be set to 0. And the process of picking a target is going to be to check a distance to each enemy to see if it is in range. We've already defined a range for the turret, so now we can iterate through the enemies. We'll say for enemy in enemy group, and then we just check the distance between the turret and each enemy. I'll calculate my x distance, which is going to be enemy.pause at index 0, which is the x coordinate, minus self.x. And then I will copy this down and repeat for the y distance. And I could use vectors here like I did previously, but I'm just going to keep this one a little bit simpler and use math throughout. Now that I have my x distance and the y distance, I can calculate the total distance using Pythagoras. So for this, we need to import the math module. I'll go all the way to the top and add it to my imports. So we'll import math, and then we go back down to this calculation. We'll say math.sqrt for square root, and then we square the x and y distances and sum them up. So we'll say xdist squared plus ydist squared. Now we know the distance to each enemy, we can check whether that distance is less than the turret's range. If it is, then we assign that to the target. So we'll say that self.target variable is equal to that particular enemy. We now want to call this method, and we'll call it in the update method. We'll come up here and just add self.pick_target and pass in the enemy group. That means that this needs to be an argument that's received into the update method. So we'll put enemy group in here. We go back into the main loop, and where we are updating our turrets here, we pass in the enemy group. And now we should be able to test this out. So I'll go in here, and once we've picked the target, I'm just going to print out to say target selected. So let's run this game, and we'll just put a turret down here. I'll select it to see the range, and then we should see that as the enemy gets closer, it now says target selected. So as soon as the enemy went into this range, the turret picked it up and it was able to fire on it. But what you might have noticed here is that the turret's target acquisition and the firing aren't really connected to each other. It's just firing on its own timer, regardless of whether it has a target or not. So we need to change our update method slightly, and we'll first of all check whether we have a target. I'll add a comment to say if target picked, and then play firing animation. Then underneath I'll say if self.target. So if this variable is not none, which means that we've picked something, then we're going to move this section here up inside it. So as long as we have a target, we're going to play that shooting animation. But if we don't have a target, well, then we want to search for new targets. So this section here gets indented, and we just tidy that up. Now let's go back and test this out again. So I'm going to put down a turret over here, and we'll just watch what happens when the enemy gets close to it. So it picks a target, it says down here target selected, and then it just keeps on shooting. So we've kind of fixed one problem, but now we've got another one. What's happening here is that once the target is picked, it's never reset. So although the enemy leaves the turret's range, it's still the target. So what we want to do is down in this play animation section, once we complete the shooting animation, we want to remove the target. So we'll say self.target is equal to none. And that puts us back into this loop again. So because we don't have a target anymore, we're going to start searching for a target. We'll just go back and run this just to see if it's worked. I'm going to put a turret over here, and it should only shoot when the enemy comes into range. And there we go. So it's taken a shot, it's taken a second shot, and now it stops. And you can see that the target selected was triggered twice. So that's the targeting working correctly. And I can remove this print statement. We don't need this anymore. The next thing that I want to look at is actually having the turret aim at the enemy as well. This will require a few more variables inside the initial constructor. We go back up to the init method, and where we have our update image section, we want to define an angle. So a starting angle is going to be 90 degrees. And then the way we're going to handle rotation is the same way as we did it for the enemies. We have one image, which is the original image. So I'm going to change this. And then from that original image, we create a rotated one every frame. So underneath here, we can say self.image is equal to pg.transform.rotate. And then we pass in the image we're rotating, which is the original image, and then the angle. I also need to make this change inside our play animation method. So down here, it's no longer the image that's being set, it's the original image, because that's the one that we're going to be using as our template to then rotate. And lastly, we need to update the draw method as well, so that at each iteration, we get a new image based on the rotated original image. So I can copy some of the code from up here, where we initially created it, and just paste it down there. So the first thing we will do inside the draw method is going to be to create our self.image, and we use the rotated image to do this. In the Pygame coordinate system, to make the turret point up, we have to subtract 90 from this angle. Then we create a rectangle from that image, and we reposition the rectangle back at self X and Y. We can go back to the main loop to test this out. So I can drop a turret down here. Now it's not going to rotate yet, but we can see that it's sitting in the correct orientation. To make it actually rotate, we need to calculate the angle when it acquires a target. We go back into our turret class and go up into this pick target section. Once we've picked a target, we've assigned that enemy into the target variable. We also want to calculate our self.angle. And we'll say that this is equal to math.degrees. And the calculation is math.atan2. We pass in minus y underscore distance and x underscore distance. And then if we go back to the main code and test this out, if I place down a few turrets, then what we should have is that as soon as they acquire a target, they quickly rotate towards it and then they shoot. So in this one, you notice they shot twice and it rotates around every time. The next feature that I want to develop for turrets is the option to be able to upgrade them. So far, when we've created the turrets, I've manually defined the range and the cooldown variables, but I actually want these to change depending on the turret's level. I have this file here, turretdata.py, and in here I have pre-populated the different levels of turret. So at level 1, the range is 90 and the cooldown is 1500, just like we've got here entered manually. And as the level goes up, the range increases and the cooldown decreases. The structure of this is that we have the turret data list, and that contains a bunch of dictionary entries inside it. So now, instead of manually defining these values here, we can use that data. We'll begin by importing it here at the top. I will say from turret underscore data, import turret data. And this is all in caps. So I'm going into this file here and I'm importing this variable turret data. Just like the other files that we're importing, you need to make sure that that file is here in the same folder as all the rest of them. Now inside the constructor, I can create a new variable called self.upgrade underscore level, and I will set this to 1. This means that when a turret is first created, it begins at level 1, and then we can upgrade it from there. Now we can replace this range and cooldown variables. We're going to instead access that turret data list, and we're going to go to the index value that corresponds to this upgrade level. So if the upgrade level or the initial level of the turret is level 1, then we want this data here. But within the list, because the index starts at 0, level 1 is actually index 0, level 2 is index 1, and so on. So what we do here in the index value is we pass in self.upgrade level -1. And that's going to give us the corresponding dictionary, but we want to extract the range, or rather we want to extract the value that's associated with the key of range. And when working with dictionaries, all we need to do here is just add .get and then pass the name of the key, which is range. I can then copy this and use the exact same syntax for the cooldown, except I just replace the final bit here with cooldown. To test this out, let's go into this data and just increase the range to something silly. So we'll put it to 290. And then when I go here and run the game, I'm going to put down a turret and then I'll click on it. Now you can see the range is absolutely enormous. So this will give us an easy way to change the variables of different turret types. We'll set this back to 90, and then we can start having a look at how to actually work through these upgrade levels. To do this, we're going to create a new method. So I'll go all the way down here, and just above my draw method, I will define a new method, which will be called upgrade. And then we'll pass the variable of self. And the first thing this method is going to do is take that upgrade level variable and increase it by 1. Once that happens, I need to make sure that I extract the correct data for that turret. So we've now gone on to the next level, so I need to replace my range and cooldown. We're already doing that in the constructor, so I can actually just copy this and paste it back down inside that upgrade method. So we'll come down here, and once we've completed that upgrade, we paste this in, and now the range and the cooldown are going to be taken again from that list, but now because we've increased this variable, it's going to go into the next index value. In addition to this, we're going to have to recreate that range circle. So if we go up here, this circle was initially created based on the range that we had at that time. So we now need to recreate this. I can copy this entire section, put it down into the upgrade method. And I'm just going to change the comment here. So now it's going to be upgrade range circle. But the rest of the code stays exactly the same. We're going to recreate all of it, but now because we have a new range, all the sizes are going to change. And now we need a way of calling this upgrade method. And we're going to do this with a button. So first of all, we need to load in an additional image for the button. I'm going to copy down this cancel button image, and I'm just going to replace it with the upgrade underscore turret image. And then we change the file name to upgrade underscore turret. Next, we use that image to create a button. Now I've got a section down here where I'm creating buttons already. So again, I'm just going to copy down the cancel button, and I will change this to upgrade. And I'll just tweak the dimensions a little bit. So it's going to be +5, 180, and then the image changes to the upgrade underscore turret image. And now that the button is created, we need to show it somewhere. So we'll go down into the game loop, and there's a section here where we're drawing the buttons. And now we have to think about when it is that we actually want to show this upgrade button. Well, the only time we want to show it is if a turret has been selected. So I'm going to come out here and add a comment to say, if a turret is selected, then show the upgrade button. And to check whether this turret is selected, we have a variable. So I can just say if selected underscore turret. So if we have one, then we can run this piece of code. But if there's nothing selected, then that variable is set to none. So this piece of code will be skipped. So we want to draw the upgrade button. We'll say upgrade underscore button dot draw onto the screen. But to actually take input from it, I need to add an if statement at the back, because this means that whenever the button is clicked, this will return a true value. So if the upgrade button has been clicked, then we want to take that selected turret and we want to run the upgrade method on it. Now let's try this out and see if it works. So I'm going to drop a turret down here, I'll click on it, and then I'll upgrade it. And there you go. You can see that the range increased straight away. Click it again, it goes up again one more time. Now this should be as far as I can go because we only had 4 levels. So what happens if I create again? Well, we get an error because we try to access a level that doesn't exist. I need to know how many times a turret can be upgraded. So I could take the length of that turret data list and use that. But instead, I'm just going to create a variable in here. And I will say turret underscore levels and set that to 4. Now back in my main file, I can add an additional check here with a comment first to say, if a turret can be upgraded, then show the upgrade button. And this check just looks at the current level. So we'll say if selected turret dot upgrade underscore level is less than c dot turret levels, i.e. there's still availability for it to be upgraded, then we can run this piece of code. So if we check this again, and I'll put down a turret here, I click on it, I upgrade it 3 times, and then the upgrade button disappears. So it's not possible to keep upgrading, and we now avoid that error. Now the upgrade is working pretty well, and we can see that as we upgrade, the range increases. But the turret image itself doesn't change. Now if we go into the assets and images down to turrets, you'll see that I have 4 different turret images. So all of these came in the sprite pack. What I actually want to do is use all 4 of them and use them as the different levels of the turret. And there's a few steps to implementing this. First of all, we need to make sure that we import all of those images. So we'll go back up here where we're loading in the sprite sheets for the turrets. And at the moment, I'm only actually loading in 1 of them. So I'm going to load in all, and I'm going to put them inside a list. I'll say turret underscore sprite sheets is equal to an empty list. Then I will use a for loop, and I'll say for x in range. So if we have a look at the image names, they're turret 1, 2, 3, 4. So I want to start at 1, and then I want to end at the maximum level that the turrets can reach. So that variable is already defined here. It's number 4, so we can only have 4 levels of turrets. So I'm going to call in c.turretLevels. But whenever you use range in a for loop, it actually goes up to, but not including, this second variable. So it's going to go up between 1 and 3. So I need to add a +1 at the end. And now once I'm in the for loop, I can start loading in each of the turret sprite sheets one by one. But I need to change this variable here. So I needed to go 1 through to 4 using this x variable here. So we can delete this and wrap it in curly brackets. And inside there, we can put that variable x. Then right at the beginning, before this quotation mark, we'll put in an f. This will use Python's string formatting. So what it does is it takes this variable and then it inserts it inside the string wherever we put these curly brackets. Then once the image is loaded, we want to add it into that sprite sheet. So we'll say turret sprite sheets dot append turret sheet. Now when we go down into our function that creates turrets, there's a section here where we create a new turret using the turret class. But at the moment we're passing in the individual sprite sheet. So now we actually need to pass in that entire list, which will be turret underscore sprite sheets. Then to match that, we go into the turret class. And now it's not going to be a sprite sheet anymore, it's going to be plural sprite sheets. Now I'll need to make sure that I catch this change everywhere. So down here in the animation variables, self.sprite sheets is equal to sprite sheets. So we just add the s to make it plural. And then we have this load images method. And if we go down and have a look at it, we're actually going to have to make a bit of a change here, because this takes an individual sprite sheet and it works out the size from it and so on. But we can't really work with this anymore, because if I change this to plural, well, that becomes a list. We can't take a size from list. So we need to pass it in as an argument. We need to pick an individual sprite sheet and pass it into this method. And that argument is going to be sprite underscore sheet. Then we can do away with this self in here and in here, because now it's just dealing with the individual sprite sheet that gets added in, or rather gets passed in as an argument. This method will work just as it did before, but of course now we need to add in this additional argument when I call the method. So we go back up here, and I can't leave this as an empty bracket anymore. I need to pass in a sprite sheet. So I go into my self.spritesheets list, and from there I need to access the index of the current upgrade level. We'll say self.upgrade level, and then it's -1, because the index always begins at 0. So for level 1, the index of the sprite sheet will be index 0. Before we go too much further, I just want to test this and see if it still works. I might run into some errors here. Okay, no, it seems to be fine. So I'm still not going to be able to upgrade the images, but at least we're loading the images itself from the original sprite sheet correctly. So now we can have a look at upgrading or changing the images as well as the upgrade. Well, let's take a look at the upgrade method again, just to remind ourselves what needs to be done. So here we increase the upgrade level. Well, that means that we now need to load the images of the next level of sprite sheet. So we need to call this method, and I can just copy this down rather than typing it all out again. So I need to load in or update my animation list, because now it's going to be using the next turret level. So we'll go and paste this down into the upgrade method just here. I'll add a comment which is upgrade turret image. I'll leave a little bit of space and I'll paste that line in here. And once that's done, I need to update my image as well. So I'll say self.original image is taken from the animation list, which is now the new animation list, at the frame index that we were on. Now let's go back over and test this out again. And this time if I place down, let's say 4 turrets, I can try upgrading them to different levels. So you can see as soon as I click upgrade, it changes to a different image. And if I upgrade them all at different degrees, you can see that's a level 1 turret, level 2, level 3, and level 4. At the moment, the process of creating enemies is done manually. If we go down here to remind ourselves, I create an instance of the enemy class and then add it into the group. What I would like to do is automate this, so that each wave of enemies is generated by itself. First, I want to add different enemy types. If I go into the assets and images and an enemies folder, you can see I've actually got 4 different enemies. I need to load all these images in. We go up to the top where I'm currently loading in the enemy images, and I will create a new variable. This is going to be a dictionary. It's going to be enemy images, and that will be equal to a dictionary. The enemies will be sorted by their strength. So the first enemy is weak, and then the value for that is going to be the associated image. Well, actually the first one that we loaded in earlier, that is the one that we're going to use. So I pass that in there and I can remove it from down here. Then I can copy this line down 3 more times. And then on the last one, make sure you delete the comma at the very end to close out the dictionary. Now I can change the names of these other enemies. The second one is medium, third one is strong, and then the last one is elite. And then we update these numbers to correspond. So it'll be number 2, number 3, and number 4. I can now pass these into my enemy class when I create them. If we go down here, we create an enemy instance here. The first thing I want to do is add an additional argument. This one is going to be enemy_type. Then I need to update the last argument because it's no longer an individual image, it's a dictionary of the images. And for the first enemy, I'm just going to define the enemy type. I will say enemy type is equal to weak. Then we go into the enemy class and we update it to match. The first thing is to add an enemy type argument here, and then to change the last argument to images. I also want to add a health variable to these enemies. So I'll say that self.health is equal to 10. Later on, we'll change the health and speed to match the type of enemy, but for now, we'll just manually enter them. Then the next thing I need to do is update this original image. It used to be assigned to the image argument, but now we get a dictionary. So I actually need to extract the particular image based on the enemy type. What I can do here is say images, which is a dictionary, .get, which will get the value, and inside here I need to pass the key. The key is the enemy type. If we now go back and test this out, we should end up with the same enemy as before. So visually nothing has changed, but we now know that it's working in this different way. So what I can do here is change this one to, let's say, strong, run it again, and now I have a different enemy coming through. So this makes it a lot easier to control what type of enemies we're getting. I'll put this back to weak for now. At this point, I can introduce the enemy data.py file. So similar to the turret data, this is a file that's going to contain a list of all the information on the enemies. So we're going to store this file in the same location as all the other Python files we have so far. The difference with this one is that it actually has 2 lists. The first one is the enemy spawn data. We'll come back to this later on when we actually come to use it. But the second list that we need is further down. It's the enemy data. And this tells us, you'll notice here, the keys are the same. So for a weak enemy type, we have health and speed. Medium, we have health and speed, and the same for strong and elite. I'll just update this to match up the indentation. So what we can now do is use this enemy data dictionary to enter health and speed variables into our enemy class. We don't have to manually enter these anymore in here. So let's load that in. To import it here, we need to import from the enemy data file this enemy data list. We'll just do this right at the top. We'll say from enemy_data, which is the name of the file, import enemy_data, all caps, because that's the name of our variable. Now we can go down here and take this health variable from that enemy data. We'll say enemy_data.get, which will get the value based on this key, which is enemy type. And let's say the enemy type we've passed in is weak. That's going to go down here, and that itself is another dictionary. Inside it, we've got health and speed. We can access these individually by adding in square brackets at the end here and putting in the name of that key, which is health. Then I can repeat this for the speed and just change this variable out to match it. If we go in and test this again, we have the same enemy from before, but let's say I change it to the elite enemy. Run this again, and now you can see he's a lot faster because the elite enemy, if we go back here, has a much greater speed variable. So we'll change this guy back to weak again. And the next step is to actually remove all of this manual work. We want the enemies to be generated automatically, so each wave to be generated by itself. This is going to be done inside our world class. This is what's going to control the spawning and the processing of enemies. I'll begin by creating a variable at the top, which is going to be self.level, and I'll begin at level 1. Then down here, I will create a couple more variables. So self.enemy_list is going to be an empty list. And underneath that, self.spawned enemies will be equal to 0. Now we're able to use this enemy spawn data at the top. So this enemy spawn data list contains a bunch of dictionaries, and each of the dictionaries corresponds to the level. I've just used comments to make it easier to identify which level I'm looking at. But this tells us how many enemies of each type we're going to spawn at that level. I want to load this variable into my world class. Right at the top, we will say from enemy_data import enemy spawn data. Now I need to extract that data. So in here I have a dictionary and it tells me how many enemies of each type I need to create. Well, within the world, I want to populate this enemy list with all those enemies. I'm going to create a specific method for that. So we'll come down here and we'll say def process_enemies. And this only takes one argument, which is self. First, we want to extract the relevant dictionary from this enemy spawn data list based on the level that we're on. So right now, if we're on level 1, then we want index 0. It's going to give us this dictionary here. I'm going to store it in a temporary variable called enemies, and I'll take it from the enemy spawn data at index self.level -1. Because if the self.level variable is 1, we need index 0. So we always need to reduce it by 1. Next, I'm going to iterate through that dictionary. For enemy_type in enemies, and that's going to iterate through each of these types. So we'll go through weak, then medium, strong, and elite. Now we already know that there's 15 and then none of the others, but we need the code to allow for all of them. Then I will say enemies to spawn is equal to enemies, which is that dictionary that I've just taken out, at index enemy type. Let's print out this variable and build this up step by step. We'll say enemies to spawn, and then we need to call this method. So I go into my main.py file, and just after I process data, I'll say world.process_enemies. Test this out, and now down here I get a little printout. And you'll see it says 15, then 0, 0, 0, which corresponds to what we've got here. So that list works out the quantity of each enemy type that we need to create. Now we can create a for loop down here. We'll say for enemy in range. And for the range, we can use that number that we just extracted, which is going to be enemies to spawn. That means that if we look at this list that we produced earlier, we're going to iterate 15 times for the first enemy, then 0, 0, 0 for the enemies after. And here, let's add another print statement. We'll say print enemy type. Go back here again, and instead of those numbers, I should now get the exact enemies that I'm creating. So if I counted these up, this would be 15 weak enemies. Let's go back and just temporarily tweak this. So we'll remove this 15. We'll say there's 1 weak, 2 medium, 1 strong, and 2 elites. We'll run this again. And now we get the exact same thing to match. 1 weak, 2 medium, 1 strong, and 2 elites. So let's set this back and continue with that automation. What we want to do here, instead of printing out each of those enemies, is we want to store them inside the list. We'll say enemy_list.append enemy type. At the end of this for loop, what I'm going to end up with is a list that contains every single enemy that we want to create. The only issue here is because we're going in order from weak, medium, strong, and elite, it means that they're always going to be generated in that order as well. So they're always going to come out weak first, then the medium, and so on until the strongest guys. But I kind of want to add a little bit of randomness to this, so that we get this list, we know how many enemies of each type we need to create, and then we shuffle them all up so that the order is random. Well, that can be done with the random module. We'll come up here and make sure we import random, and we go back into this process enemy section, and just after the for loop, or rather after the first for loop, so once this entire enemy generation is complete and we have our enemy list, we'll add a comment to say, now randomize the list to shuffle the enemies. And this is just done by saying random.shuffle, which is used to shuffle up a list, self.enemy list. Now that we've got this list created, we can always access it from our main file by saying world.enemy list. What I'd like to do next is use this list to periodically produce enemies. So rather than me manually creating the enemy instances, they're going to be created by the world. Well, for that, I need to create an additional constant variable here. And I'm just going to add a comment to separate it out. It's going to be the enemy constant. This is going to be called spawn cooldown. I don't want all the enemies to come rushing out at once, so I want a little gap in between them. And you can actually play around with this number to adjust the balance of the game. Now we go back into the main file, and right at the top, I'll need to create another variable. I will call this last_enemy_spawn, and this is going to be the current timestamp. So as soon as we begin the game, we take a current timestamp, and from there we begin the timer to see when we can start producing these enemies. Now we can go down to where we manually create our enemies, which is this section here. No, this section here. And we'll cut this out because we do need to reuse the code, but we're going to move it somewhere else. And we move it down into our main loop. Now I'm actually going to have to put this into the drawing section. I try to keep the updating and the drawing sections separate as much as I can, but with some of the code, it's difficult to force it into these categories. So down here, after we draw our groups, I will add a comment to say spawn enemies. And this spawn is going to be based on that timer. So I need to check if enough time has passed since we last spawned an enemy or since the game started. If pg_time.getTicks, which is the current time, minus the time when the last enemy was spawned, is greater than c.spawn_cooldown, which we've just created in our constants file, then we can create the next enemy. So I'm going to paste that code in from above back into here. We'll just update the indentation. And once the enemy has been spawned, I need to say last enemy spawn is equal to pg.time.getTicks. So basically I update the timer, and now we have to wait until it's passed again before we produce the next enemy. There is a slight issue here though, which is that I'm still manually defining the enemy type as weak. I need this to be automated as well. This information is stored inside this self.enemy_list variable in our world class. So the enemy list, if you remember, just looks like this. If we iterate through it, it will say weak, medium, medium, strong, and so on. So the enemy type is now going to be taken from that variable. We'll say world.enemy_list, but we need to know the index. So we need to know which of these enemies it is we're taking. Well, we're going to be working through this list one by one. And the variable that we're using to track how many enemies have spawned is also in here. It's this one, spawned enemies. I can call that variable in here and use it as the index. Then at the end, once an enemy has been created, I go world.spawnedenemies +1. This will ensure that we work through that list and we create each of the enemy types from it. Now I'll just get rid of this space here. If I run this code now, I will get an error from it. Not straight away, but it will come eventually. So before I do that and explain why the error is there, I just want you to pause the video and take a second to think about what could still be missing from this. If you don't want a hint, then pause now. But if you do want a hint, then think about what will happen with this enemy list here. Consider the fact that this variable is going to keep increasing by 1 every time we generate another enemy. Now let's run it and see what happens. So we start producing the enemies one by one, and eventually all 15 of them are going to come out. And now we get an error. And the error says list index out of range. Because we've created all of the enemies that were available inside that list, then we increase the counter by 1 more, and we try to access the next enemy, which doesn't exist. So I need to wrap this inside another if statement. we'll say if world.spawned enemies is less than the length of world.enemy list. So as long as we still have enemies left to spawn, then we continue running this code. But once we get to the end, we're going to stop, and that's the end of all our spawned enemies. And we can test this out pretty quickly. If I just change this down to say 5, run it again, and now we should be able to count 1, 2, 3, 4, 5 enemies, and that's it. So that's our entire wave. Let's go back, change that to 15, and that's the process of enemy generation now automated. We've done a lot of work now on the enemies and the turrets, so let's pull all of it together. We'll begin by going into the constants file and adding in a couple more variables. One of them is going to be health, which I will set to 100, and the other will be money, which will be set to 650. Now we can pull these into our world class. At the very top here, I'm going to say import constants as C, so that those variables become available here. And then within the constructor, just after I define the level, I will say self.health is equal to c.health, and self.money is equal to c.money. We'll be able to use these variables to make the game a bit more playable. But first I want to display them on the screen so we can actually see them changing. We go back into the main file, and first of all we need to load in the fonts that we plan to use for this text. I'll scroll down here, and just before I start defining my functions, I'll add a section to say load fonts for displaying text on the screen. And I'll define a couple of fonts. The first one will be text_font, which is going to be defined as pg.font.sys font. So pay attention here to where the letters are capitalized to make sure we don't get any syntax errors. The font I want to use is Consolas, or Consolas, I don't know how it's pronounced. The font size will be 24, and this one I'm going to make bold, so I will set the bold flag to true. Now I'll copy this down, and at the same time I'm going to create a larger font. I don't actually intend to use it right away, but since we're here, I'll just set them both up at the same time. The second one doesn't need to be bold, so I'm going to get rid of that flag, and I'll set the size of that one to 36. Now I can define a function for displaying text on the screen. You may have noticed previously whenever I've run the print function, it comes down at the bottom. Well, I want a way of showing text on the actual game window. We'll say function for outputting text onto the screen. This will be called draw_text, and it will take a few arguments. The first one is the actual text I want to display, then the font that I plan to use, the text color, and then the X and Y coordinates where I want to display this font. Since we can't put text directly onto the screen, we first of all need to turn the text into an image. I'll say that an image is font.render, and here we pass in those arguments. The first one is the text, then we pass a flag for true, and then we define the color that we want to use. So once this line is run, we will have our text converted into an image. And we already know how to work with images, we simply blit them. So I can say screen.blit, the image, at coordinates X and Y. Now that I have this function, let's go down into the game loop, and we've got our draw text or draw section down here. So just underneath, this is just temporary, we'll call the draw text function. It will be draw text. The text that we want to include will be world.health. So this is the health variable that's part of the world class up here that we just loaded in, and the money one underneath as well. So the first one will be world.health, but because it's going to be an integer value, we need to make sure to convert it into a string first. Then I will pass the font that I want to use. The color is going to be gray 100, and then the X and Y coordinates will just be 0, 0. So let's put this in the top left corner. Then I paste this down, and the second one I want to output is going to be money. So the only thing I want to change here is just the height. Now let's have a look and see how this comes up. Okay, so we can see 100 at the top, this is our health, and then 650 underneath that, which is the money. Of course, at the moment, when I click to place down turrets, I'm not subtracting anything from this. Let's define the costs associated with creating a turret and with upgrading a turret. In the constants file, under here, I will say buy_cost is 200, and then I will define the upgrade cost as 100. Now let's go into our main file and back up into the function where we create a turret. Right at the bottom of it here, we create a new turret and we add it into the group. Well, after we've done that, I'll add a comment to say deduct cost of turret. We'll say world.money is reduced by c.buy cost. So that means that the amount of money that we have in the game is going to be reduced every time we buy a turret. Let's run this now, and I've got 650, and as soon as I click, I drop 200. So I can keep going, but now I can keep just clicking more and more turrets. I need a way of checking now if I actually have enough money to afford a turret. And that's going to be done inside the event handler, because that's where we call this function from. If we go down here, this is where we call our create turret function. I'm going to add a check to this first. So we'll put a comment to say, check if there is enough money for a turret. If world.money, which is the current money that we've got, is equal to or greater than c.buy cost, i.e. if we basically have enough money to cover buying a turret, then we can create one. So now if I place a bunch of turrets down, as soon as I get to 50, I can't put any more down. Now let's do the same thing for upgrading the turrets. And that's done just slightly above in this section here. We check if the turret can be upgraded first of all, and then we show the button and we check if the button has been clicked. If that button has been clicked, we want to add another if statement, which again just checks for the money. So world.money, as long as that is equal to or greater than the upgrade cost of this turret, then we can go ahead and upgrade the turret and subtract that from the money. So minus upgrade cost. Run this again. So let's say I place down 3 turrets and then I try to upgrade one. I can't. It won't let me because I can't afford to. And this will limit how many turrets we can place and how quickly we can upgrade them. So it makes the game a little bit more challenging and you can't simply just spam turrets all over the screen. The next thing I want to take a look at is the fact that although we do have turrets placed down and they shoot at the enemies, they never actually do any damage to them. And the reason for that is that we haven't defined any damage yet. We'll go into the constants file, and at the bottom here under turret constants, I'll create a new one called damage, and I will set that one to 5. Then we go into the turret class and we look for the pick target method. This is the method that determines what enemy we're going to be shooting at. Down here, we pick a target and we calculate the angle. And just under that, we're going to add a comment to say damage enemy. Self.target.health is going to be reduced by the amount of damage. And once that's done and the turret has fired and damaged an enemy, we want to break out of this section. At this point, the turrets will do damage to the enemies, but the enemies will carry on regardless. We need to go into the enemy class and define a new method. We'll say def check underscore alive, and for now it doesn't need any arguments except for self. All this is going to do is look at its own health, which will be self.health, and if that is less than or equal to 0, then we just kill this instance. We'll say self.kill. And now that we've created this new method, we need to make sure that we call it from the update method. I'll put self.check underscore alive in here. Now let's test this out before we go too much further. I'll put down 3 turrets down here, and as they start shooting, you can see one enemy just popped away there, another one there. Each turret does 5 damage, but the enemies have 10 health, so it's going to take 2 hits from a turret. So that's why not all of them disappeared, but as they come round again, you'll see they start now getting picked off a little bit more. This does introduce a potential of a small bug, which is that as the turrets are looking for their targets in this pick target method, each turret takes a turn after the other. So if the previous turret had killed an enemy, then the next turret might still be targeting that same dead enemy and it wastes a shot. To fix this, inside this for loop, when we're looking at each of the enemies, I just add a check to say if enemy.health is greater than 0, which just means that the enemy is alive, then we're going to do all of this stuff here. We'll work out a distance and see if it's within range and so on. But if that enemy doesn't have any health left, just move on to the next one. Now we've got a way of spending money on turrets, as well as killing enemies by the turret. The next thing I want to do is add a way of earning money, which will be done whenever an enemy is killed. We go into the constant file, and underneath the upgrade cost, I will add another variable called kill underscore reward, and I will set this to 1. This way, whenever an enemy is killed, we earn 1 coin. We go back into the enemy class, and at the top I now need to import constants. I hadn't done it until this point. Just after math, I will say import constants as C. Then inside that new method that we just created, this check alive method, if the enemy has been killed, we want to award ourselves that reward money. We'll say world.money is increased by C.kill_reward. I do now need to pass this world as an argument. I'll put this in here. And the check alive method is called from the update method. So I also need to pass it through from here. And we just follow this all the way back. So the update method for the enemies is called from our main file within this update section, where we say enemy group.update. We now have to pass in the world in here. Now let's run this just to demonstrate how this works. If I put down 3 turrets and they start shooting, so you notice it's gone up 1, 2, because we've killed one enemy here, 2, 3, and 4 at the end. So every time an enemy gets killed, our money goes up by 1. And that's the money mechanic pretty much working. We've got a way of spending money on new turrets and upgraded turrets, and we've got a way of earning money from killing enemies. We will also eventually get a reward for completing a wave, but we'll come to that later on. For now, I want to move on to the other variable I added into the world class, which was health. We start with 100 health, and the idea is that every time an enemy gets all the way through from one end of the path to the other, we lose 1 health. To monitor this, we have to go into our enemy class and into the move method, and we actually already have a way of checking for this. Down here, we were checking if the enemy has reached the end of the path. At this point, we deleted the instance, but we can also subtract 1 from world health. This means that we also need to pass it as an argument in here, and we need to pass it as an argument in here where it's first called. We don't need to trace it back any further because the update method already receives the world argument. We can test this out now, but it does take the enemies quite a while to get around. So what I'm going to do is just add 1 elite enemy to that first wave, because that enemy goes around quite quickly. So if I run this, the first few guys are going to be these slow guys, but it should eventually, looks like it's going to be the very last one. This elite enemy comes through, so keep an eye on the health up here. We've got 100 at the moment. And as that enemy goes off the screen and past here, it drops to 99. So let's go and get rid of that elite enemy before I forget. And now a lot of the game mechanics are complete. There was a lot of jumping back and forth between the different classes there, but the reason for that was because we were tying all of them together. So now all of these classes interact with each other. We have health and money that goes between each of the classes depending on what's going on. I want to continue building out the detailed game mechanics now and tying all those different classes together. The first thing I want to do is have a way of starting the game. So rather than having the enemies just instantly rush out as soon as we launch the program, I actually want some time to think about it, lay out the turrets, and then have a button that says begin game or something like that. For that, in the main file, I'm going to add an additional game variable. And this is going to be level_started. I'll set this to false to begin with. Now I can create a button to start the game. I'm just going to copy down the upgrade button image, and I will change this out to begin, well, it's not turret, so it's just begin_image, and then the file name is begin.png. Now we can go down to here where the buttons are being created, and again I'll copy down the upgrade one, and I'm just going to change the naming a little bit, so it's going to be the begin button, and it uses the begin image. I'll move it a little bit, so I'm going to change this 5 to 60, and then the Y coordinate I'll change to 300. Now we can go down and implement this inside of the game loop. Down here is where I'm drawing all the buttons at the moment, and I have this spawn enemy section. Right now the spawn enemy section is just run instantly. That's why the enemies come out as soon as we start the game. But instead I'm going to put this inside of an if statement. I'll add a comment first of all to say check if the level has been started or not. And this is where I'm going to use that variable we just created. So if level started is equal to false, meaning we haven't begun the level, then we want to display that button that we just created, which is going to be begin_button, and we'll call the draw method and put it onto the screen. And to check if this button has been clicked, I can just add an if statement to the beginning of it. If this button is clicked, then we want to change that trigger variable level started to true. And now I can put an else statement underneath here and indent all of this inside of it. Now, as long as this level started variable is false, we're going to be displaying the button and we're not going to spawn any enemies. But as soon as we click that button, this trigger switches to true and the else condition is now met, so we can start creating enemies. Let's run this just to test it out. So now nothing's happening, there's no enemies, and this gives me time to set up, put some turrets down, and then as soon as I click begin round, that's when the enemies start to come out. Now I want to go a little bit further and start actually tracking the enemies that have been killed or the enemies that have gone all the way through to the end of the path and they've been missed. To begin with, I go into the world class, and inside the constructor I'm going to add a couple more variables. First one will be killed underscore enemies, which will be set to 0 to start with, and the second one is going to be missed enemies, which is also going to be 0 to begin with. Well, this will allow me to track, first of all, how many enemies I'm spawning from before, but now how many of those I've killed and how many of those I've missed. Now we can look at how to actually track these. Both of these methods can be tracked from the enemy class. If we go in here, we already actually have a section here, which is our check alive method that looks at whether that enemy has been killed. Well, if it has, we're already passing the world class into it. So we can just say world.killedEnemies is increased by 1. And likewise, for any enemies that have gone all the way through and were just completely missed, we have a section up here in the move method where we're looking at whether the enemy has reached the end of the path. At the end of this one, we can do the same thing, but now it's going to be the other variable, which is missed enemies, and we increase that by 1. Now let's go back into the world class and just recap on this. First of all, we have this variable that's going to be updated at the beginning of the round, and it's going to tell us how many enemies we've spawned. But then we have a variable that tracks how many enemies we've killed and how many enemies we've missed. What I want to be able to do is track whether we've completed the wave. And the only way to know whether a wave is completed is by looking at how many enemies have been killed and how many enemies have gone off the screen. So basically, if there's no enemies left on the map anymore, that means that that wave is finished. We've got this variable here, which stores all of the enemies that we're going to create for this wave. And then we have two counters, one for how many we've killed and one for how many we've missed. So you might already see where I'm going with this. If I just add both of these variables together and I compare them to the length of this list, if they're equal, then that means that all of the enemies that have come out in this wave have been either killed or they've gone off the screen. Therefore, the wave is finished. Now we can implement that logic. I'm going to come down here and just above the draw method, I'm going to create a new method which we will call check_level_complete. And then we pass self as an argument, and this is just going to be one if statement. It's going to say if self.killedEnemies plus self.missedenemies, if that total is equal to the length of the self.enemy list, then that means that that wave and that level is complete. We're just going to return true. Now we need to be able to call this method from somewhere. If I go back into my main loop, I can add it in down here. Where we were previously working on the level started variable with this enemy spawning section, I can just go directly underneath that, add a comment to say check if the wave is finished. And this is where we call that method. We'll say if world.check_level_complete. If that returns a true value, then that means that all of the enemies have been dealt with. They have either been killed or they've gone off the screen. So we can set our level started variable back to false. Let's test all of this out now. I'm going to go back into the enemy data and I'm just going to change it to have only one enemy so that we can run this a little bit quicker. If I run this and I drop a few turrets down, as soon as I begin the round, the enemy comes out and he's dealt with. Now the begin round button returns. So now I can start the new round because we've just detected using the method that we just implemented that the round is finished. That enemy was killed and there was only one enemy in that whole level. So now I can click begin round again, but nothing happens anymore. We don't seem to start the new wave. That's because we're starting the same wave. So we're basically just continuing where we already were. That enemy is already killed, so there's nothing else to follow up. We need to add a whole bunch of resets in this section. First of all, we need to move on to the next level. We already have a variable for that inside the world class, which is level. So I'll say world.level is increased by 1. Then we also need to reset a couple of variables. So one of them is that last enemy spawn variable. So this controls when the enemies come out, and it just gives it a little bit of a cooldown. Well, we reset this back by taking time.get_ticks. Well, that resets the variables that are in the main file, but what about the ones that are in the world class? So these variables here are important as well, because we track how many enemies we killed and we missed, but every wave we have to reset this back to 0. And to handle this neatly, I'm going to create a method specifically for resetting. We'll come down here and we'll define a new method called reset_level. We'll pass self as the argument, and then I'll add a comment to say reset enemy variables. So the first one is going to be the enemy list. I need to put this back to an empty list, because each wave has different sets of enemies, and that's controlled by this enemy data file. So I need to clear what we had before and just start with a new list again. And then I just reset the variables from up here. So I'm actually just going to copy them down. It's the spawned enemies, killed enemies, and missed enemies. We're starting a new wave, so all of this needs to go back to 0. Now we go back into our main game loop, and we just continue this section here. So when a wave is completed, we reset a bunch of game variables, but we also want to run that world.reset_level method. That's going to set everything back again. It's going to clear everything out, but now we've moved on to the next level. So what we actually want to do is regenerate all the enemies for the new level. And that's done with a method that we've already used, which is world.process_enemies. If I just go back here to remind us what that does, it's down here. It just works through all of the enemy spawn data for that particular level. But because we've just moved up to the next level, it's going to go in here and it's going to go into the next one and say, okay, now we've got this many enemies, run through them all and stick them into this new enemy list. This should now give us all of the functionality we need to be able to start a level and complete a level and move on to the next one. So let's just visualize this and then test it out. I want to be able to display the level number on the screen. So I'm going to copy this draw text function that I've used for the health and the money, and I will just add in level. So all I do is move it down a little bit, and if we run this again, so now we can see this is the health, the money, and we're on level 1. So let's just drop down a few turrets and then begin level 1. The enemy will come through, gets killed, and now we've moved on to level 2. So in the background, all of that stuff with reprocessing the world has now been done. So back there in memory is now a new wave of enemies all ready to go. If I click begin round, we now get the next wave coming through. One other thing that I'd mentioned in the previous section is that whenever we kill an enemy, we gain 1 coin. But when we complete a level, there should also be a reward for that as well. I'm going to create a new variable in this constants file called level_complete_reward, and I will set this to 100 coins. Now we can go back into the main file, and in that section where we were checking if the wave is finished, right at the beginning, I'm going to award that money. I'll say world.money is increased by c.level_complete_reward. And now I'll just test this out. So I'm going to drop down a few turrets first of all, and then we've got 50 coins at the moment. So we'll run this game, and once we kill him, we gain 1. So we go up to 51, and then we also get 100 for the bonus for completing the wave. So we've got 151. Now we've got the mechanics working for checking if we've completed a wave, we've killed all the enemies, or maybe some of them got through. But what about the other way around? What about if the enemies get through and we lose? Well, I'm going to test this out by first of all going into the constants, changing the health down to 1, and then just to speed this up, I'm going to add an elite enemy to wave 1, just because they move a lot faster. So if I run this, we've got our health at the top, we've got 1 health, and this guy's going to get through defenses because we have none. So when we get to the end, this should just go to 0, and that's fine, but the game just continues. So if this guy goes all the way around as well, we're going to go to -1. So there's not actually any way of losing this game. To add that in, I'm going to begin with a couple of extra variables. We'll go up to the top of our main file, and up here where we're defining these variables, I'll create a couple new ones. So first will be game over, and I will set that to false. And another one will be game_outcome, which I'll set to 0, but I will add a comment to explain what it should be. So if I set this to -1, then is a loss, and 1 is win. So this way I'm just going to use this one variable to determine whether the game has been won or game has been lost. Now we can implement these variables. We'll go down to this section where we're drawing all of our buttons and we're checking if levels started and so on. All of this is kind of our game logic. So I'm going to add an overall if statement here to wrap all of this inside of. I'll say if game over is equal to false, well, that means that we want to continue doing all of this stuff. So as long as the game is running, we want to do all of these updates. We're going to highlight all of this stuff all the way down to the event handler, but just above it, and indent it by 1. Now all of this only occurs as long as the game over variable remains false. Next, I need a way of checking whether the game is actually over. Because right now this variable begins as false and it stays as false. We've got no way of changing it. I'm going to go into the updating section up here, and before we get into updating the groups, I'm actually going to do an initial check. I'll say if game over is equal to false, so just the same as what I did below, then check if player has lost. And this is based on the world health variable. If world.health is less than or equal to 0, well, that means that game is over. So we'll set game over to true, and I will also use that game outcome variable. And I'm going to set that to -1 because a -1 is a loss. I also don't want the enemies moving around and the turrets shooting the targets during this section. So if the game over variable is false, then all of this stuff also needs to be moved into the right. So all of that is indented inside the game over check. Now if I run this game and I just begin the round, we've got 1 health and you can see everything moving okay. But as soon as the enemy gets to the end, that will change the variable over to true. And that stops the game. So now the enemies aren't moving anymore. We can't put down any more turrets or anything. So effectively, it kind of looks like everything is frozen up. At that point in the game, we want to be able to display some kind of message to the player, some kind of feedback, and then an option to restart the game. For that, I need to first of all load in a new image for a restart button. We come up here and we'll just copy down the begin button. And I'm going to rename this to restart. So we can delete this and call it restart. Next, I'll go down a little bit to where my buttons are created, copy this one down, and I'll just do the same again. So this is now my restart button. I'm going to adjust the positioning a little bit so I'm not relative to the screen width anymore. I'll just set this to 310 and 300 for the Y coordinate is fine. Now I need to decide when I actually want to show this button. Well, the rest of the buttons are being drawn down in this section here. I have my if game over is equal to false, and that pretty much captures the entirety of all the button drawing that's going on. But the restart button should only come up when game over is true. So if the game is finished, we've lost the game, or we've won the game, we want to be able to see that restart option. And that means that this is going to be put underneath an else statement. So I need to line up with my if statement up here, scroll all the way down, and just above the event handler, with the correct indentation, I add in an else. This else section is when the game is over. For whether we've lost or won, this is what we want to display. First of all, I'm going to display a little rectangle on the screen. I'll say pg.draw.rect, goes onto the screen. Then for the color, I've just picked one of the named colors. So it's Dodger blue. You can pick whatever you like for this. And then I need to define X and Y coordinates, a width and a height. And lastly, just to make it a little bit nicer looking, I'm going to add rounded edges to it, or rounded corners. I'll say border underscore radius is equal to 30. Then I want to display some text. But this text is going to be dependent on whether we've lost the game or we've won the game. For now, the only one I'm dealing with is a game loss. I'll say if game outcome is equal to -1, that means that the game has been lost. So the text I'm going to draw is going to be game over in all caps. Then for the font, I'm going to use the larger of the two. So this is going to be large underscore font. Color will be gray 0. And then the X and Y coordinates are 310 and 230. And underneath this, I'm going to add a comment to say restart level, because this is where I'm going to have my restart button. I can put my restart button in here, call the draw method onto the screen, and for now I'm not going to add any logics, I'll just say pass. So to test this out, I think a way of speeding it up actually is just going to set the health to 0. that means that I don't need to wait for the enemy to go round. Just straight away, the game is over. So this is looking like I want it to. I've got this little rectangle in the middle, game over, and then a restart game button. Right now, clicking this does nothing, but that's what we can have a look at next. We're going to go into this section that I've had a pass inside of, and now we just want to reset everything because we're completely starting the game from scratch. We're not just moving from one level to the next, we're restarting the whole thing. That means a whole bunch of variables need to go back to the original state. First of all, game over goes back to false, seeing as we've just restarted. Level started also goes back to false to give us the option to prepare for the game. Then the other variables like placing turrets, that goes back to false. Selected turret goes to none. Then we refresh our last enemy spawn, which is pg.time.getTicks. So we're going to take a new timestamp. And then we even recreate our world instance because we want that to be completely reset. So we can say world. In fact, I can just copy this because this is what we already used at the very beginning when we first initialized this. I can just copy these 3 lines and put them inside this restart section. So just update the indentation. Now we're going to create our world instance, which essentially just resets it back to all of the original variables that we had in the constructor. We'll then process the data and we'll process the enemies. I also need to get rid of any enemies that are still potentially in memory, as well as clear all of the turrets. Because both of those are stored inside groups, I can just say, add a comment here to say empty groups, and then call the name of the group, which in the first case is enemy_group, and run the empty method. That's just going to empty out that group. So just like a list, this is going to empty out any of the contents. And I can do the same thing for the turret. Now to test this, I will need to set the health back to 1 because I actually need the game to run for a little bit. And I'm going to run it to this and actually place a turret down just to see whether they get cleared out. So as this enemy runs around, I'm going to pick a turret as well just to see if everything goes back to fresh. So we've still got a turret in place. With this guy, everything is frozen, and then I'll hit restart. And now it's just back to how it was at the beginning. We've got 1 health, 650 money. Even though I placed turrets previously, everything has gone back exactly how it was. And if I click begin round, it just goes how it was from the beginning. Now we have a condition for game over. So basically, if we lose the game, we've got a way of handling that. But what if we complete the game? So not just finish a level or finish 1 wave, but we actually finish all of the waves. What happens then? In order to be able to work out whether I've completed the game, I need to know how many levels are actually in the game. We go back into constants and add a new variable called total_levels. And for now, I'm just going to set this to 1 to test it out. In reality, there's 15 levels that I've created, and you could actually expand this quite a lot. It's just the length of this enemy spawn data. So you could create as many more as you'd like, but I've limited to 15 for now. For the purpose of testing, we'll say that we only have 1 total level. We go back into our main file and into the updating section up here, and we add a second check. The first one was to check if the player has lost. Underneath that, I will add another one that says check if player has won. And this check is based on the current level. We'll say if world.level is greater than c.total levels, well, that means that we've completed all of the levels that were in the game. If that's happened, then I could just copy this down because the result is the same. The only difference is the outcome of the game is now a 1 instead of a -1. We now need to account for this in our reset section down here. So at the moment, we've got a check that says if the game outcome is -1, so if we've lost, then we display this text. Well, I'll add a second one, which will be elif game outcome is equal to +1. Then we do more or less the same thing, but we draw slightly different text. Now it's going to say, surprise, surprise, it's going to say you win in all caps. And because the text is slightly different length, I'm actually going to move it over to the right a little bit. So I'm going to position it at x-coordinate 315. Now let's test this out, and just to make it a little bit easier for us, I'm going to get rid of that elite enemy, because now victory condition is based on us quickly completing this level, and since it's the only level, it's going to win us the game. So I'm going to place down a few turrets. This is our health, our money, and then the current level is 1. We'll begin the round. We kill the enemy, and now that's the same game over screen from before. So we've gone on to level 2, but of course there's only 1 level in total based on that new variable. So that triggers this game over section. If I restart, it's the same logic as before. So now we just restart the whole thing. And this really ties together most of these classes and brings together a lot of the game mechanics that we're missing. So the only things really left now are just to add on a little bit of polish and tidy up the display a little bit. The next feature that I'd like to add is a way of fast forwarding the game. Because once we start a wave, we kind of just have to wait for the enemies to go around. So what I would like to do is be able to have a button that I can just hold down and it just doubles the speed at which everything happens. And this is going to need a new button. I'm going to go down to where the rest of my buttons are here, and I'll just copy the restart button down. So the restart image now becomes, if we get rid of this, it's going to become fast_forward. And then I can create a button to match it. So down here, I'm going to copy down the restart button. No, actually, I'll copy down the begin button because it's going to be in the same position pretty much. I'll just change this. So from begin, this becomes fast_forward. Then the position is going to be plus 50 pixels and the Y coordinate will be 300. So that's okay. One thing I'm going to do differently here though is change this trigger at the end from true to false. This trigger determines whether the button is a single click or whether it is a click and hold. All of these ones up here are just single clicks. But the fast forward actually needs to be a click and hold. So as long as you're holding it down, the game is going to go twice as fast. Next, we need to incorporate this variable into our world. I'm going to go to the top of the world class, and underneath the level, I will create a new variable called self.game_speed, and I'll set it to 1. Self.game_speed, there we go, set to 1. We can now use this variable together with this new button inside our main game loop. We'll go down to the section where we're spawning enemies, so just in here, inside the else statement, but before we actually spawn the enemies, add a comment to say fast forward option. And by default, I'm going to reset the world game speed to 1. So I'll say that the speed is equal to 1. And then I'm going to display the button, which is the fast_forward button. We'll call the draw method, just like all the other buttons, pass the screen. And if that button is clicked, then I want to change that world.gameSpeed variable to 2. And let's just demo this out. So it's not actually going to speed anything up, but let's print this level variable out. So game_speed. If we run the game, we're going to see down here, once I start the round, it's saying 1. But as soon as I click this button and hold it, it changes to 2. Release it, it goes back to 1. I need to now incorporate this variable inside of the way the turrets and the enemies move. So we'll get rid of this print statement, we don't need that anymore. And we can now go into the enemies, so we'll deal with the enemies first and we'll come back to the turrets. Go into the move method, and this is the section that actually controls the enemy's movement here. I'm already passing world as an argument to the move method, so that means that I can call the game speed variable from here. And I'm just going to use it as a multiplier. I use self.speed in a couple of places here. I'm now going to wrap it in a set of brackets, and I will multiply it by that game speed variable. Say world.game_speed. And then I can do the same thing and just replace the one down here. Now both of my speed variables are dependent on this game speed variable. So if I change this game speed variable globally, it's going to affect how fast the enemies move. If we now go back to our main game and run it, I'll begin the round so you can see him just strolling along at the usual speed, but as soon as I click and hold fast forward, it now moves faster. So this allows me to change the pace at which the game works. I now need to do the same thing to my turrets. So we go up to where we are actually processing the update methods, and the enemy group, well, that receives the world class, so that's why I didn't need to do anything there in terms of arguments and imports. But the turret group doesn't, it only receives the enemies as an argument. I'm going to add a second argument, which is going to be the world, and then I go into my turret class update method, which is down here. So there's the enemy group that already receives as an argument, and I add a second one, which is world. The enemy speed is controlled by the speed variable, but turrets are a little bit different. They're not moving, but they do have a way of controlling how fast they shoot, which is based on their cooldown. It's this variable here. I can apply the same logic back to here. I can make this cooldown a variable that's dependent on the overall game speed. But now rather than multiplying it, I want to divide it by the game speed. So we'll say world.game_speed, because the faster the game goes, the lower the cooldown. Now we can demo this, and first of all I'm going to go into the enemy data and put this back to how it was before, where I have 15 weak enemies coming out at the beginning. If I launch this again and I just put down a few turrets down here and I start the game, I'm going to play around with the speed and you can see how it varies. So this is the normal speed, and then when I fast forward you can see that everything's now going twice as fast. The enemies move twice as fast and the turrets respond to them twice as fast. Now we're kind of in the last stages of this game development, so what I'd like to do is just tidy up the display a little bit. We're showing some variables up here, and these buttons are kind of positioned funnily, so let's just tidy all that up and create a much nicer looking display. I'll start off by creating a new function for this. I'll go to the top here where I'm creating my draw text function, and underneath there's going to be a new function which is def display_data. This doesn't need any arguments, and I'll start with a comment that says draw panel. I'll create a couple of rectangles which will be pg.draw.rect. They go onto the screen and the color is maroon. And then we need to define a few coordinates here. So first of all is going to be the start point x and y coordinates. So that's screen width 0. Then it's going to be the width, which is the side panel, and the height, which is c.screenHeight. Now let's go down and call this function. So before I go too far in developing it, we go into the draw section here, and just above all these draw texts, which we're going to move shortly, we're going to call that function, which is display_data. And if I run this, I now have this panel over here. Now we can add on the next bit. What I'm going to do though is I'm going to cut this text out of here because we're going to move it into this display data function anyway. So we'll stick it in here, and then I'll move around and reorganize it properly in a second. But the next thing I want to do is put in another rectangle. So I'll copy this code down, and now this one is going to have a different color. It's going to be gray 0, so it'll be black. X and Y coordinates are the same, width is the same, but the height I'm going to set to 400 pixels. And then I will set another argument here of the line weight. So if I set this to anything other than 0, then it's going to give me a hollow rectangle. If I call this again, now I've got this outline that kind of separates the two areas. So this is the area where my buttons and my GUI is going to be. And previously, to make sure that I could clear the screen entirely, I was running this line down here, screen.fill. I don't need that anymore, so I can get rid of this section, because now the entirety of the screen is being filled either by the map or by this new side panel that we've just created. The next thing I want to do is add in some more images. So we go up to here where I'm loading the images at the moment, and just underneath the buttons I will add a comment to separate them out. So this is going to be GUI, and I'm just going to paste them in rather than having to type them all out. You already know how to load images by now. The images here are going to be used for the GUI, so they go into assets, images, GUI, and then in here I've got a logo, a heart, and a coin icon. And that's what I'm loading in here into each of these images. Now we can start to finalize our display data function. The first thing I want to do is say screen.blit, and I want to pass in that logo. It's going to be at x coordinate screen width and the y coordinate of 400. Let's run that, and now I've got a little logo down here. Then we'll add a comment here just to separate things out, and this will be display the data. So the first part of this function was just to draw the panel and things like that. Now we want to actually output some of this information. The first thing is going to be the level. So I actually want to move this draw text function to be the first one. And I will add at the beginning of it, level, leave a space, and then plus what I had there previously. I also need to reposition it so it's not sitting in the left hand side. The x coordinate will be screen width plus 10 pixels, and the y coordinate is 10. Now let's see how that looks. Okay, so that's much better. We've got a little display here. Now let's move the health and the money over as well. But in addition to just showing out the text, I want to draw in those little icons. So we're going to put screen.blit in between these draw text functions. The first one will be screen.blit heart image, and the coordinates will be c.screenWidth plus 10 pixels, and y coordinate is 35. And then we can leave this draw text for the health in the same place. We don't need to add any text at the beginning, but I just need to update the X and Y coordinates. And this one, again, I'm using screen width as a reference because that's kind of where the game window ends, or rather the map area ends, and then we move on to this side panel. And then it's 40 for the Y coordinate. Now we're going to blit the next one, so I can just copy this down as well. Now instead of heart image, it's going to be coin image. Oops, coin image. The coordinates will be +10, and this one moves down to 65 pixels on the y-axis. And finally, the draw text will leave money as it is, but we just need to update X and Y coordinates. Let's just copy this down from here so that we don't have to keep retyping it all. So the X coordinate is fine, Y coordinate goes to 70. Run it again, and now it looks a lot nicer. So we've got level 1, little heart here to indicate how much health we've got, coins, and so on. At the moment though, the buy turret isn't sitting centrally positioned, and there's actually a reason for that, which is that I want to show the price next to it. So let's go down to where we're drawing this button at the moment, which should be somewhere down here. Right, it's this section here, so draw buttons, button for placing turrets. So before I actually get into that code, I will add another little comment here to say for the turret button, show cost of turret and draw the button. Now I just want to draw the text, which corresponds to how much this turret costs, and show the little coin icon. I'm just going to paste this in again. You've seen me type this just a few minutes ago. So we call the draw text function, we pass in the buy cost, which is how much it costs to buy a new turret, and these are the X and Y coordinates. Then I'm going to blit that same coin image just at these new X and Y coordinates. If we take a look, now it looks a bit nicer. So we've got this price next to the buy turret. What I'd also like to do, if I put down a turret and select it, I get the upgrade turret button. Let's do the same thing here as well. We'll put the price next to that one. And that happens just slightly below. It's this section here. We say that as long as we're able to upgrade, i.e. the turret isn't already maxed out, then we show the upgrade button. Well, just before we show the upgrade button, and again, I'm just going to paste this in here, we're going to show the cost of the upgrade button, and it's done with this draw text function. These are the X and Y coordinates, so screen width plus 215 and 195 for the Y coordinate, and then we draw that coin image just next to it as well. If we take a look now, place down a turret, select it, and now we've got these kind of lined up nicely on the X-axis, and they're lined up horizontally and vertically with their own buttons. I'd previously messed around with some of these variables, like health for example is set to 1, just because we were testing something out. But now that we're almost done with the game, let's set all this back to how it should be. So health should be 100, and total levels needs to be 15. That's how many levels I've got in this game. Now the very last thing that I want to do, just to finish this game off, is add some sound effects. I deliberately leave that to the very end, because otherwise they kind of get in the way of the tutorial recording, basically. So we need to first of all load the sound effects in, and we do this in the same way as all other assets. We go up to the top, so I've got my images here, so these are my button images, my GUI images, and underneath that, in a separate section, we add a comment to say load sounds, and it's going to be, well, first of all, you name it, you assign it to a variable. It'll be shot_fx pg.mixer.sound, and then the file location, which is going to be assets/audio/shot.wav. This particular sound effect was a little bit loud, so I actually want to reduce the volume. I'll say shotfx.set_volume to 0.5, so it'll be 50% of the original volume. Now we need to take this sound effect and we need to pass it over to our turret. So as soon as we create a new turret, which is done in this create turret function that I just scrolled past. So it's down here. When we create a new turret, we want to pass that sound effect into it. So we'll add it as an argument, and then we go into the turret class, and in the constructor, we need to receive it as an argument, shotfx. Then we make sure to assign it to a self variable. So I'll just do it down here underneath where I calculate the center coordinates and stuff like that. Add a comment to say shot sound effect, and say self.shot_fx is equal to shotfx. And now lastly, we just need to play this sound effect. And that's going to happen when we pick a target to shoot at. So this pick target method is where that happens. Right at the end of it is where we look at whether the distance to the enemy is less than the turret's range, and if it is, that becomes our target, and we even do damage to it at that point. So just after that, before we break out of this, we'll add a comment to say play sound effect, and to play it we just call the name of that sound effect, which is shot_fx, and call the play method on it. Now all that's left to do is just test this out, place down a few turrets, and begin the round. And there you have it, a complete tower defense game made from scratch with multiple enemy types, numerous waves, and upgradable turrets. A lot of work went into this tutorial, so if you found this useful, then please leave a like and consider subscribing, because it really helps to support the channel. And if you have ideas for any specific tutorials that you want to see in the future, then let me know below in the comments. Thanks for watching.